Hello students, welcome to ACE Online. So in this live session, we are going to discuss the solutions to the mock exam which is for the BARC examination. So before getting into the solutions, so here we have the information. So ACE Engineering Academy is conducting online test series for this prestigious BARC examination 2025. Now to access this test series, you need to scan this QR code, complete the registration process. So we are conducting 5 full-length mock exams. We will also provide their video solutions. So we are conducting this YouTube live for that. These are the various streams for which we are conducting this. If you want the schedule, so here is the schedule. You can look at the schedule. So for EC, Electrical, CS, Civil, Mechanical, the schedule is like this. There are 5 full-length mock exams. So already the test has started. You can enroll for this. And in today's live session, we are going to discuss with you the solutions. So if you have any issues with the questions, you can also comment in the live. We will respond to your comments. So let's start the discussion. So first let's start with engineering mathematics. So look at this question. This is from system of linear equations. They gave 3 equations and they are asking which of the following is not true. So you have to identify the statement which is not true. So what we usually do is write this in the augmented matrix form. So come on, write the augmented matrix 1, 2, 1, 3. Next 0, A, 5 and then 10. Next look at the equation, look at the coefficients. It's 2, 7A. So 2, 7A and then B. So what we usually do is we convert this into row echelon form. It's a very simple task. You need to convert this into row echelon form. So how do you do that? So you can write like this. R3 is replaced with R3 minus 2R1. So already this is 0, so no need to worry about that. So the new elements are like, so the first row is retained 1, 2, 1, 3, 0, A, 5, 10. And next it is 2 minus 2 is 0, 7 minus 4, what is 7 minus 4? It's 3. And then A minus 2 is A minus 2 itself. And then B minus 6, B minus 6. So what next? You need to convert this into row echelon form. So for that, you have to use this element and make this 0. So how do you do that? So how shall we do that? Maybe I'll write like this. R3 is replaced with, so let's multiply. So how do you make this 0? Can I multiply like this? So A into R3 minus 3 into R2. So can I write like this? So what happens here? I get 3A and 3A minus 3A would be 0. So this is like 1, 2, 1, 3. And then the second row is same, 0, A, 5 and then 10. And then it is 0. So 3A minus 3A is 0. So this is 0. A square minus 2A minus 15 equal to 0. You have to go for the factorization. A square minus 5A plus 3A minus 15 equal to 0. So if you look at the factors, the value of A would be 5 and minus 3. When A is 5, this would become 0. So if this becomes 0, then the rank of A cannot be 3. So A should not be equal to 5 and A should not be equal to minus 3. Yes, this is true. But they asked clearly which of the following is not true. So I'll just write that this is true. Similarly, go for the next option. The system has infinitely many solutions if A is minus 3 and B is minus 4. So they are asking you the values of A and B. Now for infinitely many solutions, the rank of A should be equal to rank of AB, but should be equal to, or it should be less than number of variables. So for that we want this to become 0. Yes, this becomes 0 whenever A is minus 3, and this should also become 0. So how can this become 0? Let me put A as minus 3 here. So this is minus 3B, and then plus 18, minus 30, and this also has to be 0. This is 12 going to the other side. So this is minus 12. So the value of B would be how much? It would be minus 4. So when B equal to minus 4, so when B is equal to 4, B equal to minus 4, this is also 0, this is also 0, that leads to infinitely many solutions. This is also a true statement. The system has no solution if A is 5 and B is not equal to 12. Now let's see what happens. A is 5. Now when A is 5, this becomes 0, then what happens to this? When A is 5, this is like 5B, and then minus 5. So 5 into 6 into 5 is 30, and then minus 30. And he says B is not equal to 12. Suppose if B is 12, then it is 60. 60 minus 60 would be 0. So when B is not 12, this element is non-zero and the system has no solution. This is also true. So by elimination, so this is the right answer for the question. So let's look at the next question. He gives a matrix A, then says an eigenvector corresponding to the largest eigenvalue. So you need to find the largest eigenvalue. There are 3 eigenvalues. Can you quickly find the 3 eigenvalues? So for that, it's 1 minus lambda 0 0 0, 2 minus lambda 1 2 0, 3 minus lambda. So I'm writing the characteristic equation. You equate this to 0. So let's expand the determinant. It is 1 minus lambda into 2 minus lambda into 3 minus lambda and then minus 0. So this has to be equal to 0 because these 2 elements are 0 anyway. You clearly have all the factors. The eigenvalues are 1, 2, 3. The eigenvalues are 1, 2, 3. The largest eigenvalue is 3. Now you have to find the eigenvector corresponding to the eigenvalue 3. Or you can also go for a verification. Ax should give you 3x. So let me go for the verification. Let me just verify 1, 0, 1. I have to get 3 times of this. So will I get 3 times of this? Let me check. So this is 1, and then no, I'm not getting 3 times of this. This is eliminated. So I'm checking the next option. 0, 1, 1. I have to get 3 times of this. There is no way, because this into this when multiplied is, yeah, this into this is giving me 0. When I multiply the second row with this, what happens? So 2 plus 1, 3, that's fine. When I multiply this with this, I'm getting 3. So when 3 is taken common, so this is like 3 times 0, 1, 1, yes. So this is definitely an eigenvector corresponding to lambda equal to 3, that's it. Now they gave f of x, which is ax plus byx, and has the least value at x equal to what? And they are also giving us a is greater than 0, b is greater than 0, x is greater than 0. It's a simple maxima minima problem. So find the stationary points. So what is f dash? F dash is a, and 1 by x derivative is minus 1 by x square. So this is like minus b by x square. You have to equate this to 0. When you equate this to 0, let's see what are the values. So it goes here, b by x square equal to a. I need x square or x value. So something like what? Plus or minus a by b, and then you have the under root. So this is the stationary point. Clearly is at x greater than 0. So eliminate the negative value. You only have one valid stationary point, that is root of a by b. And let's also check the second derivative to confirm whether it's a minimum or not. What's the second derivative? It is 0 and then plus, it is 2b by x cube. Now when you put root of a by b, this is definitely greater than 0. Second derivative greater than 0 confirms that it's a point of minimum. So what's the question? Has the least value at x equal to what? At x equal to root of a by b. That's the right answer. Now this is clearly a direct problem on Cauchy's mean value theorem. So f of x is given, g of x is given, interval is given. According to Cauchy's mean value theorem, it is f dash of c by g dash of c equal to what? It is f of b minus f of a by g of b minus g of a. Substitute all this information. What is f dash? It will be like 4c cube divided by what is g dash? It is 2c equal to, you have to substitute this information. So f of x is x power 4, so it is 2 power 4 minus 1 power 4 is 1 whole divided by g of b minus g of a. So 4 minus 1. There is a cancellation. So what is left is 2c square equal to what? 16 minus 1 is 15 by 3. So 5. So what's the value of C? C square is 5 by 2 and the C value is root of 2.5. Do we have such options? Yes, so that's the right answer. So here we have, let A and B are the events in a sample space. He says P of A and P of B are non-zero, then which of the following is always false? So we need to identify the statement which is always false. A and B are mutually exclusive. Yes, two events can be mutually exclusive, there is nothing wrong about it. A and B are independent. Yes, two events can be independent, there is nothing wrong about it. A and B are either mutually exclusive or independent. Yes, they can be either mutually exclusive or they can be independent. But simultaneously, two events cannot be independent and mutually exclusive. Now that's what is mentioned here. A and B are mutually exclusive and independent. This cannot happen. This is the false statement. So the answer is option D. So these are the questions from engineering mathematics. So the next subject will continue.
We are going to discuss COA questions. First question, watch question carefully. In IEEE 754 single precision floating point number written in the hexadecimal form, the decimal value of 3F000000 with base 16 minus BF8 follows 5 zeros with base 16 is, means he expressed the 32-bit notation in hexadecimal and in IEEE single precision notation he asked the result in decimal. Means first find the decimal value for first number, second number, later get the operation. Here operation is nothing but subtraction. First of all, to find the decimal value given for the IEEE single precision notation, standard expression is -1 whole power s into 1.m into 2 power biased exponent minus biasing value. In this expression, capital E represents biased exponent value. In this, first of all, 3F000000, it is in hexadecimal. First, its binary value is 3 means 0, 0, 1, 1. F means 1, 1, 1, 1, remaining all are zeros up to total 32 bits. In this, MSB represents a sign. Next 8 bits are used to represent biased exponent 1, 2, 3, 4, 5, 6, 7, 8. Capital E value in our style, nothing but mantissa. So from this, if you find the decimal value for the biased exponent 1, 2, 4, 8, 16, 32, 64 like that, nothing but 126. S is equal to 0, M value 0. From this, value is nothing but minus 1 whole power 0, means it is nothing but positive, into 1 point, M value 0 into 2 power minus 1. So finally its value is nothing but 1 into 2 power minus 1 means it is nothing but 0.5. So first number answer is 0.5 in decimal. Come to second number. BF8, remaining all are zeros. BF8, remaining all are zeros. Its size is 32 bit. That's why 8 hexadecimal digits are needed. B means 1011. F means 1111. 8 means 1000. Remaining all are zeros up to 32 bit. So in this also, MSB represents sign. Next 8 bits are used to represent biased value, biased exponent value 1, 2, 3, 4, 5, 6, 7, 8. It is nothing but mantissa. Here its value is nothing but 127. Convert the binary to decimal, then you get 127. So its value is minus 1 whole power 1 into 1.0. Mantissa value is 0. Nothing but 2 power 127 minus 127, nothing but 0. Means its value is nothing but minus 1. So come here. Here it is nothing but minus 1. So he asked the decimal value for this operation. 0.5 minus of minus 1 means 0.5 plus 1 means 1.5. Correct answer is 1.5. Come to second question. Here, tricky question it is. Watch question carefully. Excellent question it is. The size of ROM required for implementing 16 cross 1 multiplexer is, to implement a 16 cross 1 multiplexer, what is the size of the ROM required? In this, first of all, to design 16 cross 1 multiplexer, we require 16 number of data inputs, 4 number of selection lines, and only one output. These are the parameters needed to design a multiplexer. So in this, 16 number of data inputs and 4 selection lines. These are considered as address because address is applied at input. That's why not only data input, selection inputs also. So number of address bits needed for ROM is nothing but number of address bits. Number of address bits needed for this ROM is nothing but 16 plus 4, 20. Next, number of outputs only 1. Why only 1? Because multiplexer generates only one output. That's why output is considered as data. That's why from this, address size is 20 bit, data size is 1 bit. So what is the ROM size here? 2 power, number of address size 20, data size is nothing but 1. So correct answer is 2 power 20 into 1 bit. Correct answer B. So in this you remember one point. While implementing a function with ROM, number of inputs act as the address and outputs act as the data. Here multiplexer has only single output. That's why only one data line is sufficient for this. But while computing the number of address lines, not only data inputs, selection lines also considered. That's why total number of address bits is equal to 20. So ROM size is 2 power 20 because standard expression is 2 power n into m bits. What n tells? Number of address bits, m tells number of data bits. Come to next question. Okay, come to next question. Small twist is there in this question. First, read all options carefully. Hardwired control unit is preferred in the design of CISC processor, advanced processors, only in RISC processor, RISC type processors and other processors where the speed is essential parameter. Correct answer is D. Here, hardwired control unit is faster over microprogrammed control unit. Why option A is wrong? CISC processor uses microprogrammed control unit. Advanced systems also use only microprogrammed control unit because hardwired control unit is costlier. Next, only in RISC processor. RISC processor uses the hardwired control unit, but here problem is only in the RISC processor, only is the problem. Come to option D. RISC type processors and the processors where the speed is essential parameter. Example is nothing but not only RISC processor, another processor which uses the hardwired control unit is nothing but DSP processor, digital signal processing unit. That's why correct option is a D. Come to next question. Excellent question it is. Watch question carefully. Consider the following instruction sequence in a 5-stage pipeline. Number of stages in the pipeline is 5. The stage names are IF, instruction fetch. In any pipeline processor, first stage is nothing but instruction fetch. Next, instruction decode and effective address calculation. Next, operand fetch. Next, execution. Next, write back. These are the 5 stages. Means it is the basic processor. It is not a classic processor, it is basic processor. If it is a classic processor, after completion of execute, memory access will be the next unit. Next, come here. Instructions are given like this. First one, add R1, R2, R3. R2 and R3 register content are added. Result is placed in R1. Next, subtract R4, R1, R5. Operations are mentioned. Next, multiplication. Registers are mentioned. What type of data hazards is/are present in the sequence? While executing the program, which type of conflicts occurred by the processor? Now in this, only RAW, read after write, also known as a true dependency. Only RAW and WAR. WAR means write after read, anti-dependency. WAW means write after write, output dependency. Here, option A only RAW, option B only RAW and WAR, option C only RAW and WAW, option D no hazard. Here, if you watch these instructions, how to find the RAW? Here, for finding RAW, it is the first instruction, it is the second instruction, it is the third instruction. In these 3 instructions, in second instruction, input registers are R1, R5. R1 is present at the output of the first instruction, means first instruction output is used as the input in the next instruction, not only in second instruction, third instruction also. Because of that reason, RAW present, true dependency. How to find the WAR? Now, in second instruction R4 output register, it is not present in the first instruction, but in third instruction R5 is the output register. It is present in the second instruction as input register. That's why it is nothing but WAR. WAR also present. WAR. There is WAR between I3 and I2 means instruction 3 and instruction 2. Next, what about WAW? In first instruction output register is R1, second instruction output register is R4, third instruction output register is R5. All those registers are different. That's why WAW does not present. To present WAW, one of the minimum 2 registers in the output of the specified instructions must be same. That's why that situation is not there. That's why there is no WAW. So what about correct answer? Only RAW and WAR. Correct answer is B only. It is wrong. Why option A is wrong? Only RAW. It is wrong. Why option D is wrong? Hazards are there. No hazard means it is wrong. So correct option is B. Come to next question. Tricky question it is. Consider a magnetic disk pack with 32 surfaces. Number of surfaces is equal to 32. In our style, H represents number of surfaces, 2 power 5. 128 tracks per surface. T is equal to 128 means 2 power 7. And 256 sectors per track. S is equal to 256 means 2 power 8. In one track, 256 sectors are there. And 512 bytes in a sector. B is nothing but 2 power 9 bytes. If the inner track diameter is 21 centimeter, inner track diameter is 21 centimeter, what is the maximum recording density in that track? He asked the maximum recording density in that track. If you watch the options, he asked the recording density means bit recording density per centimeter, because in all options he mentioned the value in centimeter. So in this, first find the perimeter. Perimeter expression is nothing but pi into D. Pi into D. Here, perimeter of a track it is. Here, you find the one track data storage capacity. It is nothing but number of sectors in one track. Nothing but 2 power 8 means 256 into number of bytes in one sector. 2 power 9 means 512 bytes. So, pi into D. Nothing but area of circle. So here pi is nothing but 22 by 7 into given diameter is nothing but 21 centimeters. Here this perimeter is used to store this value number of bytes, not bits, bytes. So for 1 centimeter, how many bytes it can store? Nothing but 256 into 512 divided by, here pi is nothing but 3.14 means pi value to 21. If you compute all those things, you get the value in bytes, because he mentioned the sector size in bytes, not in bits. So if you compute all those things, you get 2k bytes. 2k bytes, not bits. 2k bytes in 1 centimeter. So correct answer is A. Why answer B is wrong? He mentioned 2k bits per centimeter. Okay. Next, come to next question. Excellent question it is. Consider a processor with 150 distinct instructions and 30 general purpose registers. Number of registers fabricated in the processor is 30. Number of operations permitted by the processor is 150. A 32-bit instruction word has an opcode, the register operand, and an immediate operand. Read question carefully. A 32-bit instruction word has an opcode, one register operand, and an immediate operand. Assume that the immediate operand is expressed in the signed to 2's complement notation. Immediate operand is expressed in the signed to 2's complement notation, but not unsigned value. Then the smallest negative value of the immediate operand is dash. Smallest negative value or smallest value, it is also sufficient. In this, watch this one. First, understand the instruction format. Here, nothing but opcode, also known as operation. Next, register. Next, immediate value, IV, immediate value. In this, maximum number of operations permitted by this one is 150. That's why minimum number of bits required in this field is nothing but log 150, means you require minimum 8 bits because 7 bits are not sufficient. Number of registers fabricated is 30. That's why register field is nothing but log 30, means 5 bit. Total size is 32 bit. Already he mentioned clearly. He mentioned this value clearly. That's why number of bits allocated for immediate value is nothing but 19. This immediate value is expressed in the signed to 2's complement notation. That's why with 19 bit, the range of the data to be expressed in signed to 2's complement notation. To be expressed in signed to 2's complement notation. Nothing but minus 2 power 18 means minus 2 power n minus 1, 2 plus 2 power n minus 1 whole minus 1, 2 plus 2 power 18 whole minus 1. He asked for the smallest value. That's why minus 2 power 18 means 2 power 8 into 2 power 10 means 1024. If you want to get exact value, here 256 into 1024, nothing but minus 262144. It is the smallest negative value to be represented in this format. So minus 262144. So correct option is B. Come to next question. Here, while executing an instruction, the memory read operation is needed in execute cycle for. He asked the memory read operation is needed in, not in instruction cycle, execute cycle. Here, register addressing mode instruction. In register addressing mode instructions, processing registers are used to supply the operand. No memory visit is needed because the registers are used to supply the target operand. That's why it is wrong. Immediate addressing mode instruction. In this, the instruction supplies the target operand. No memory visit is needed in the execute cycle. Memory visit is needed only for the fetch cycle. For fetch cycle, memory visit is needed for any type of instruction because fetching is the compulsory operation for executing any instruction. It is the elementary primary operation. Next, absolute addressing mode instruction. Yes, absolute addressing mode is also known as direct memory addressing mode. In this instruction supplies the effective address. Example is like this: move R1 bracket of 3500. Instruction directly expresses the address of the operand. Now effective address is 3500. At this address, whatever the data we stored, that data will be supplied to R1 register. That's why option C is correct. Why option D is wrong? Implied addressing mode instruction. If it is implied addressing mode, no operand is required. That's why memory visit is not needed to read operand. That's why it is also wrong. Correct option is C only. Next, come to next question. Read question carefully. First, understand the question. A 4 KB direct mapped write back cache. Type of cache memory is not write through cache, write back cache. Is organized as multiple blocks with block size of 256 bytes. One block size is 256 bytes. The main memory capacity is 1 gigabyte. Main memory capacity is 1 gigabyte. The cache controller maintains the tag information for each cache line comprising the following. Number of valid bits is 2, number of modified bit is 1, and number of dirty bit is 1. The total size of tag needed for this cache controller means tag directory is dash bits. First of all, if you watch the question carefully, main memory and cache memory are expressed in bytes only. That's why we consider word size is nothing but byte. Means byte size and word size are same. Size of a word and size of a byte are same. That's why in this, to solve this question, watch this one. MMW means number of words present in main memory, 1 giga. 1 giga means 2 power 30. MMW means number of words present in main memory. CMW means number of words present in cache memory. 4K means 2 power 12. Type of mapping is direct map. First you find the only tag field size. Tag field size is nothing but, if it is direct mapped cache, PA minus CA. You can find the value directly with this expression because main memory and cache memory are expressed in the same units. Then not needed to consider the remaining parameters, nothing but 18 bits. Later, it is write back cache. For each cache line, what he mentioned, let it is cache line. CL means cache line number. Each cache line, what he mentioned, 18 number of tag bits are needed. Along with this, number of valid bits 2, modified bit 1, and dirty bit 1, total in addition 4 bits. So each cache line requires 22 extra bits. Here, to find the tag directory, with metadata bits, expression is nothing but T plus extra bits. Extra bit means valid bit like that. These are compulsory required for each cache line into CL means number of such type of cache lines present in the cache memory. To find the number of cache lines, CL value, look here, cache memory size is 4 KB and each block size is 256 bytes. That's why first to find the CL value. CL means number of cache lines present in the cache memory. 4K by or 4 KB by 256 byte. Byte get cancelled. 4K means 2 power 12, 256 means 2 power 8, nothing but 2 power 4, nothing but 16, nothing but, already we found this value, nothing but 22 into 16. If you compute 22 into 16, you get exact value 352. So correct answer is B. Okay, come to next question. What is the average memory access time for a machine with a cache hit rate of 80%, where the cache access time is 30 nanoseconds and miss penalty time is 400 nanoseconds. He mentioned miss penalty time but not miss time. Here, it is 2-level memory and he mentioned the miss penalty time. Now, TCM, access time of cache memory is nothing but 30 nanoseconds. Next, miss penalty. Given miss penalty is nothing but 400 nanoseconds. Next, hit rate. Hit rate of cache memory 80% means miss rate is 20%. Means processor reads the words 80% from cache memory and remaining 20% from main memory with miss penalty of 400 nanosecond. Now, what about the expression for the same? Average memory access time, AMAT, average memory access time is nothing but HCM into TCM plus 1 minus HCM, nothing but miss rate, into, what is the miss penalty he mentioned? 400 means nothing but, find the main memory access time, it is nothing but 400 nanosecond plus 30 nanosecond. If he mentioned only miss time, then not needed to consider the 30 nanoseconds. We multiply with only 400. That's why. Substitute these values here. Nothing but 0.8 into 30 nanoseconds plus 0.2 into 430 nanoseconds. Here, 0.8 into 30 means 24 nanoseconds plus, here nothing but 86 nanosecond, nothing but 110 nanosecond. For this calculation is not needed. Directly we can calculate the same. So, correct answer is option A, 110 nanosecond. Come to next question. Tricky question it is. It is the last question from COA subject. Come to this question. A magnetic hard disk has 25 platters with 2 number of recording surfaces. Means H value is nothing but 50. What H tells? Total number of recording surfaces. Generally, one head is used for operating one surface. That's why number of heads is equal to number of surfaces. Next, 512 tracks in each surface. T is nothing but 2 power 9, 512. Each track has 64 sectors. Means S is equal to 2 power 6. Next, and one sector size is 256 bytes. Number of bytes present in one sector is 256 bytes. Now, the motor is operated with 9,000 RPM. RPM is nothing but 9,000. It is not RPS. RPM, revolutions per minute. Next, let the number of logical cylinders in the hard disk is X. Let the number of logical cylinders present in the hard disk is X. And the average rotational delay is Y. The average rotational delay is Y. X represents the number of cylinders present in the hard disk. Then X and Y values are means respectively. For this, first you find what is a cylinder. Logical cylinder means, if you don't know the definition for this, it is impossible to solve this question. What is logical cylinder? It is the collection of, logical cylinder is the collection of all tracks, collection of all tracks in the same relative position. It is very, very, very important. Same relative position. From all the surfaces means in any surface T0, track 0 is there. Collection of all the T0s is nothing but C0. Collection of all T1s is nothing but C1, cylinder 1. Here, number of cylinders present in hard disk is nothing but number of tracks present in one surface. That's why what about T value he mentioned? 512, nothing but C value. C means number of cylinders. From this, here A and D are false. Correct answer can be B or C. Next, what about Y value? Number of cylinders present is 512. Next, what about Y value? Y value is nothing but average rotational delay, also known as average latency. First, to find this one, use the given RPM value. Given RPM, revolutions per minute, simply rotations per minute, 9000. RPS, rotations per second, 9000 by 60, nothing but 150. Means motor is going to complete 150 rotations in 1 second time. That's why what about one rotation time? One rotation time is nothing but 1 by RPS is nothing but 1 by 150 seconds or 1000 by 150 millisecond, because he mentioned the values in, he mentioned the options in millisecond. That's why 1000 by 150 millisecond, nothing but its value is nothing but 6.666 millisecond. It is the one rotation time. Average latency is nothing but half rotation time. That's why average latency is equal to 1 rotation by 2 means 3.33 milliseconds. So if you watch the options, already we computed number of cylinders present is 512. Next, average rotational delay is 3.33. That's why correct option is B. Our colleague, Mr. Srinivas, will follow the same.
Hello everyone, myself C.H. Srinivas, faculty at AS Engineering Academy. Currently I am handling algorithm and data structure subjects. So today I am here to discuss solutions regarding algorithm and data structure subject questions. Okay. So these questions asked in mock test 1. So let us take first question. This question based on master theorem topic. Read the question. The asymptotic upper bound solution for the recurrence relation given by T of n equals to 2 times of T of n by 2 plus n by log n is. So first you need to understand standard form of recurrence equation by using master theorem. Okay. So let me write down the standard form of recurrence equation by using master theorem. So T of n is equals to A into T of n by B plus theta of n power k into log to the power of Pn to the base B. So it is a standard form of master theorem. There are some restrictions on A, B also, where A value is greater than or equals to 1 and B value must be greater than 1 and K is greater than or equals to 0. I can say P value is real numbers. Okay, P value is real numbers. So this is a standard form of the master theorem. Now in this master theorem there are 3 cases. Okay, the first case A greater than B to the power of k case, second case A equal to B to the power of k, the third case A less than B to the power of k. Now compare this equation, compare the given equation with the standard form of the master theorem and get the values of A, B, k values. Okay, just compare here A is equals to 2 and B equals to 2. So by comparing the master theorem, A equals to 2, B equals to 2, we can rewrite this equation as n into log to the power of minus 1 n. So it means that we can rewrite it as n into log to the power of minus 1 n. By default we have to assume that base value equals to 2 here. So therefore by comparing the standard theorem of master theorem, it is n to the power of k, n to the power of k format. So therefore k value is equals to 1, whereas log to the power of p, p value equals to minus 1. So therefore p is equals to minus 1, right. So we are rewriting this equation in the form of standard form of the master theorem. Afterwards verify 3 cases. So clearly here it is in the form of A is equals to B to the power of k case. Okay, just check the concept like is A is equals to B power k or not. Obviously A value is equals to 2, B value is equals to 2 and k value equals to 1. Yes, A is equals to B power k case satisfied. Under A equal to B power k, again 3 sub cases are there, P greater than minus 1, P equal to minus 1 and P less than minus 1, whereas here they already provided it is P equals to minus 1. So according to our classroom notes, so it belongs to second case, under second case it belongs to second part of the master theorem. Okay, then the solution for this one is T of n is equals to theta of n to the power of log A to the base B into log of log n to the base B. So it is a standard solution for the second case of the master theorem. Substitute the values of A, B and see the result. So theta of n to the power of log A means 2 base 2 log of log n base 2. So we can write log 2 base 2 value equals to 1. So it is theta of n into log n. So therefore which is equals to theta of n into log n base 2. As we know that theta is the asymptotically tight bond, whenever it is satisfied for theta, we can write theta is nothing but in terms of big O and big omega also. Therefore we can also rewrite this solution in terms of big O and big omega. According to the options they provide in terms of big O notation. Therefore the correct answer for this question is order of n log n. So this is the question asked based on master theorem second case, friends. Okay, right. Next question. This question based on optimal merge pattern. Just read the question. Find the minimum cost of the merging 10 files whose lengths are, they provided length of files and the condition is you are allowed to merge only 2 files at a time. You are allowed to merge only 2 files at a time. So we want to find minimum number of or minimum cost. Okay. So what is the basic principle for solving this question? The first step is you have to arrange all files in the increasing order of their record lengths. Okay, arrange all files in the increasing order of their record lengths. So if I arrange all files in the increasing order of the record lengths, obviously we are having increasing order like 1. Let me write down first. So like first file is 1 and second one is 3, sorry, second one is 2, after 2 next one is 3, next 4, afterwards 5, next again we are having 5, then we are having next value is 10 2 times, next 15 and then 20. So we have to arrange all files in the increasing order of the record lengths. That is the first step you should remember. Afterwards, in each iteration, you need to select 2 files which are having least number of records and merge them into single file. Okay, it is step number 1. Step number 1. So now these are the 2 files which are having least number of records. So we have to merge them into single file. So if I merge these 2 files into single file, then I'll get an intermediate file. Total number of records in this file is 3 records. Okay, so one file is having 1 record, another file is having 2 records. So we can merge these 2 files into single file. The total number of records are here 3. Now verify, are they in increasing order or not? Yes. Now how many files are there in your hand? Total number of files are, initially we are having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Initially we are having 10 files. But after completion of first step, how many number of files in your hand? 9 files. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 files are there. Again you have to repeat this process. What is the process? In each iteration, arrange all files in the increasing order of their record lengths and then select 2 files which are having least number of records and merge them into single file. So clearly they are already in the increasing order, that's why I don't want to arrange them in increasing order. Directly I can write it as step number 2 also. Okay, step number 2. So merge these 2 files into single file. So 3 plus 3, that is equals to 6. Right? Now how many files in your hand? 1, 2, 3, 4, 5, 6, 7, and this is the file which is having 6 records. Okay, total 7 files are there right now. Okay, sorry, total 8 files. 1, 2, 3, 4, 5, 6, 7, 8 files are there. Again select 2 files which are having least number of records and merge them into single file. So clearly if I go to next step, step number 3, arrange all of them in the increasing order of the record lengths. So we have 4, 5 and then 5. Afterwards we are having 6, next 10, 10, 15, 20. It is essential that every step you need to arrange the files in the increasing order. Okay. Now select 2 files which are having least number of records and merge them into single file. So clearly here 4 and it is 4, it is 5, 4 plus 5, that equals to 9. Merge them into single file, that equals to 9. Now count how many files in your hand. 1, 2, 3, 4, 5, 6 and it is 7th file. Again arrange in the increasing order, which is step number 4. So we are having 5, 6, 9, 10, 10, 15, 20. Select 2 files which are having least number of records and merge them into single file. Okay. So here it is 5 and 6. Merge them into single file, we'll get 5 plus 6, that equals to 11. Like this. Okay. Now remaining how many files? 1, 2, 3, 4, 5, 6 files are there. Okay. I will continue, there is no space here, therefore I will continue in this step only. Now select 2 files which are having least number of records. What are they? File having 9 records and 10 records. Merge them into single file. 9 plus 10, that equals to 19. Okay. Now how many files in your hand? 1, 2, 3, 4, 5 files are there. Again select 2 files which are having least number of records. So clearly it is having 10 and it is having 11. So merge these 2 files into single file. Okay. Then step number 6. we are having 10, 11, 15, 19 and then 20, right. So merge these two files into single file. 10 plus 11, that equals 21. Okay. Now next step, step number 7. Again select two files which are having least number of records. Obviously it is 15, 19, 20, 21. I can merge these two files into single file, which is equals to 34. Right. Total how many files in your hand? 3 files now. One file contains 21, another file contains 34, another file contains 20. Now arrange them in the increasing order, that is step number 8. Just arrange the increasing order, you will get records like 20, 21, 34. 20, 21, 34. So merge these two files into single file, which we are having 41. Okay, 41. Now again step number 9, arrange the increasing order, that is 34 and then 41. We are having total number of records are 75. Okay. So in this problem they are asking find the minimum cost of merging. Cost means with respect to here minimum number of record movements. Minimum number of record movements, friends. Okay. So therefore minimum number of record movements, how we are getting in this case? First step we are having 3. 3 plus 6, 9, right? 9 plus 9, that is 18. 18 plus 11, that equal 29. 29 plus 19, that is 48. 48 plus 21, that equals 69. 69 plus 34, that is 103, right? So 103 plus 41. 103 plus 41, that equals to 144. 144 plus 75, that equals to 219. Therefore total number of record movements, that equal to 219. So total number of record movement means that is minimum number of record movement, that is nothing but your total cost. Okay. So answer this question is 219. The basic principle is every iteration we need to arrange files in the increasing order of the record lengths. Okay. Next problem. Dash strategy breaks up a problem into a series of overlapping subproblems and building up solution to a large and larger subproblems. So this is a basic principle in dynamic programming. You know, dynamic programming algorithm is rely on principle of optimality. Okay. So therefore this is the principle of optimality case. So option C is the correct answer. Okay. Next one. Consider the following set of messages M1 to M6 with the following frequencies. So they provided frequencies of letters, and using Huffman coding with the convention that left branch is assigned with label 0 and right branch is assigned with label 1, and decode the tree. This process same as optimal merge pattern just now which I explained. Okay. So what we have to do, just arrange all letters in the increasing order of their frequencies. Just arrange all letters in the increasing order of their frequencies. Afterwards, in each iteration, select 2 letters which are having least frequencies and then start construct binary tree by assigning least frequency letter as left child and the next least frequency letter as right child. So same process, whatever I explained the optimal merge pattern, same process I am going to continue here. Okay, but it's easy process. I don't want to repeat the same process here. So you have to construct binary tree for the given sequence. After constructing binary tree, simply traverse this message from root towards leaf. From root towards leaf. Okay. So in that case, you will get answer. This question is option D. Option D. The solution already given because it is same as optimal merge pattern. That's the reason I am skipping the explanation part. Okay. The solution already provided here. Okay. Next question. Which of the following is true for computation of time in insertion, deletion and finding maximum minimum element in a sorted array? If the array is already sorted, we can easily find maximum and minimum. So minimum is first index where max means last index element, right? So therefore, if array is already sorted, minimum element in the array and maximum element in the array can be found with only order of 1 time. Look at the options here. Here they mention maximum is 1 and minimum is 1. Maybe it is correct. Okay. Here they mention maximum is order of n, minimum is order of n, which is not correct, friends. Okay. If the array is already sorted, minimum occurs at first index, maximum occurs at last index. Therefore, option B is not correct. Here it is minimum is order of 1 and maximum is order of 1. Maybe it may be correct. Okay. Next, here it is maximum is order of n, which is not correct, so we can ignore option D. Now competition between A and C. Remember, whenever array is already sorted, the moment if you insert any element into the array, then existing structure may get disturbed. For example, if I draw simple example, assume that array is already sorted, we are having elements like 10, 20, 30. Just assume that indexes are starting from 1. Okay. Now I want to insert an element which is, let it be 19. I want to insert an element 19. So to insert an element 19, so first we have to insert an element 19 into 4th index. Afterwards you have to readjust the array because array must be sorted, right? You have to readjust the array because array must be sorted. In that case, you need to perform comparison with each and every element. Therefore, in the worst case, it takes up to n comparisons. Okay, I hope you are understanding. The moment if you insert element into the sorted part of the array, then the existing array may get disturbed and it may lose its structure. To maintain again sorted structure, we need to readjust the array. Therefore, insertion will take order of 1. Not only insertion, if you delete one element from the array, again it may lose the structure of the array, again you need to sort the array. Therefore, insertion and deletion both will take order of n time. Okay. So therefore, answer to this question is insertion order of n, deletion order of n, finding maximum order of 1, finding minimum order of 1. Okay. Next, which of the following recurrence relation represents searching an element from the balanced binary search tree? Actually here the word is missing, that is binary search tree. It is a binary search tree, friends. Okay. What is the basic principle in binary search tree? For example, if I consider a tree just imagine binary search tree concept. If we consider a root node, it is not only for root node, it is applicable for every node. Okay. For every node, values or keys at left subtree. Values or keys at left subtree of that node X. Assume that this is the node X. Then values or key values of left subtree of node X must be less than the node X. Okay. Sometimes we can take equal values also. Okay, but DBMS point of view, primary key violation is there, therefore duplicate elements are not allowed. Okay, general definition point of view, values at left subtree of node X must be less than or equals to value of X, and values of right subtree of node X must be greater than or equals to values of X. This is a definition of binary search tree. Okay, so in that case, first if you want to search an element, first you are going to compare root node. Assume that the tree contains n elements. The time required for searching an element from out of n element is T of n. First, to whom I am going to perform the comparison? I am going to perform comparison with root node. Okay. After performing comparison with root node, in the worst case, that element may not find at root place. Then, based on the key value, either I have to move towards left part of X or you have to move towards right part of X. For example, if this key value, whatever key value I am going to search, if it is less than X, you have to move towards left side. In the left side, at most how many elements we are having? N by 2 elements are there. Therefore, the time required for searching a key out of n by 2 element is T of n by 2. So therefore, first compare with the root node. If root node is not matching, it is taking either left subtree or right subtree. Therefore, the recurrence equation is T of n equal to T of n by 2 plus C. Okay. It is binary search tree. Please add this word binary search tree. Okay. So answer to this question is T of n equal to T of n by 2 plus C, friends. Okay. Next question, these models we already covered in the class. Okay. So whenever I is equals to n, I greater than 0, I equals to I by 2. Means the value of I every time it is reduced by half. In that case, how many times this loop will be executed? How many times loop will be executed? You just start like this. Initially I value is starting from where? I value is starting from n. This is called first iteration. Okay. After first iteration is over, I value is reduced by half, that is n by 2. It is second iteration, right? When it go to third iteration, again this value will be reduced by half, that is n by 2 by 2, that is n by 2 square. If you go to fourth iteration, it will again reduce by half, n by 2 square by 2, n by 2 cube. Like that we are continuing up to, how long we will continue? We will continue this process as long as I value greater than 0. What is the least value greater than 0? Obviously it is 1. So therefore, assume that we are continuing up to kth term. At kth term, we are reaching the base condition that equals to 1. Okay. Now look at the structure. If it is first term n, second term n by 2 power 1, third term n by 2 square, fourth term n by 2 power 3. If I continue up to kth term, it should be in the form of n by 2 power k minus 1. N by 2 power k minus 1. Now assume that it is reaching the base value of the given algorithm. So what is the base condition means? As long as I greater than 0, the loop will be executed. So what is the least value greater than 0 means? Obviously it is 1. If I go one more iteration, it means if I go one more iteration, k plus 1 iteration, automatically this value becomes 0. Then we can stop the process. Okay. So in that case, how many times this loop is running? It means I want to find the value of k. How to find value of k? From here we are going to find value of k, right? So therefore, so let n by 2 power k minus 1 is equals to 1. By taking cross multiplication, n is equals to 2 power k minus 1. Find the value of k from this. Okay. So k minus 1 is equals to, if I bring 2 this side, it is acting as log n base 2. So k is equals to 1 plus log n base 2. So based on the value of n, it may take floor or seal. So how many times this loop is running means 1 plus log n base 2 times it is running, which is nothing but log n base 2, because we are ignoring the constant value in asymptotic notations. Okay. Now what about inner loop? J is starting from 1, it is reaching up to n, but every time it is incrementing by 1 step. In that case, it will take n steps, right? So it will take n steps. Okay. Means for each value of I, inner loop is running n times. But how many times outer loop is running? 1 plus log n base 2 time. So therefore, this instruction will be executed as 1 plus log n base 2 times we are running outer loop. Each time we are executing inner loop is n. Therefore, it should be 1 plus log n base 2 into n. So by multiplying n plus n into log n base 2. Which is dominating term here? N log n is dominating term when comparing to n. Therefore, we have to take dominating term in asymptotic notations. In asymptotic notation, we have to take dominating term. Therefore, answer to this question is order of n log n is the correct answer. Okay? Order of n log n is the correct answer. Next. This question based on graph traversal, that is a DFS. The basic idea of DFS is, depth first search is, you need to traverse the graph in deeper direction until you encounter a node whose adjacent node have already been visited. Okay? In DFS, nodes get visited in deeper direction until we encounter a node whose adjacent node already visited. In that case, you have to apply backtracking to process remaining nodes. That is a basic principle in DFS algorithm. Okay? Let me start here, friends. Okay? For example, identify the valid DFS. Imagine 16 is nothing but V6, 8 is nothing but V8, because here we mention nodes in terms of V1, V2, V3. So just we are giving numbers here. It means that V6, V8, V7 like this. Okay? Let me start first option. Is it valid or not? Like V6, V8. Start from V6. So this is the node where we have to start from V6. From V6 they are moving to V8. So from V6 to V8, it is correct because V8 is the adjacent node of V6. Yes, it is correct. Afterwards from 8 they are moving to 7. From V8 it is moving to 7. Clearly we started from V6, we are moving in deeper direction by traversing adjacent nodes. Okay. After V7 they are traversing to V5. So after V7, who is the adjacent node? That is V3. So in DFS we need to traverse the tree in deeper direction until we encounter a node whose adjacent node already visited. But here if you see V7, adjacent node is V3, which is not yet visited, right? So therefore after V7, correct node to be visited must be V3, friends, okay? But to whom they are visiting? That is 5, which is not correct. So therefore ignore first option, okay? Ignore first option. Now look at second option, friends. Second option starting from 6, 6, 3, 1, 2. Slowly I am increasing the speed. 6, 3, 1, 2. So if I start from 6, V6, from V6 they are traversing V3, which is correct because adjacent node of V6 is V3. After 3 they have to traverse V1. So V3 to V1, which is also correct, and V1 to V2, yes, V1 to V2, which is also correct. V2 to V4. See, after V2 we can traverse V2 to V4, means we started from V6, V3, V1, V2, V4. After V4 they are traversing to V5. Tell me, after V4, who is adjacent node of V4? Adjacent node of V4 is V8. So we started our journey from V6, right? We are visiting nodes in deeper direction until we reach a node whose adjacent node already been visited. But if you see V4, there is a adjacent node which is not yet visited. Therefore after V4 we have to traverse V8, but they are traversing to V5, which is not correct. Okay. Next, look at which is the wrong option here. See, 6, 3, 7. Let me change the color. 6, 3, 7, 8. Just verify, friends. 6, 3, 7, 8. So 6, 3, 7, 8, which is correct, right? 6, 3, and then 7, and then 8. We are starting from 6, 6 to 3, and 3 to 7, 7 to 8. After 8, they are traversing to 5. Yes, which is correct, right? After 5, they are traversing to 2. So V2, which is also correct. V2 to V4. So V2 to V4, which is also correct. After traversing V4, then actually we need to traverse to V8, but V8 already visited, right? So therefore, adjacent node is already visited, means you have to apply backtracking. So apply backtracking to V2. From V2, you have to visit unvisited node, that is V1. So therefore, after V2, we can visit V1, which is correct. So option C is the correct. Then where is the mistake in option D? 6, 8, 5, 4, 2. So start from 6, 6, 8, 5. After 5, we cannot visit 4, friends, okay? We cannot visit 4. So look at once again, 6, 8, 5. After 5, we need to traverse to V2. So therefore, we cannot visit V4. Therefore, answer this question is option C is the correct answer, okay? Yes, next question. It is based on hashing concept, friends, okay? Hashing concept. There is a hash function h of k equals to k mod 10. There is a hash function h of k equal to k mod 10, and they provided set of key values. And the question is, what is the index of bin? Bin means here, what is the index of the location in which the last record is to be inserted, right? What type of collision resolving technique they are using? Here they are using collision resolving technique is linear probing. Linear probing is a collision resolving technique, okay? Linear probing explains that, for example, if I take h of k is equals to k mod m, just assume that h of k equal to k mod m, where h is a hash function, k is the key, and m is the hash table size. Suppose if it is hashing to ith location, if it is hashing to ith location in the hash table, if ith location already occupied by some other key, then collision occurs. To resolve the collisions, we can use variety of collision techniques. linear probing, quadratic probing, double hashing, and then separate chaining. In linear probing, if ith location collision occurs, we have to go to I plus 1th location. If I plus 1th location also collision occurs, we have to go to I plus 2 location. Like that, how long we need to continue this process? Actually here hash table size is m, right? M. The hash table size is m. Indexes of the hash table are looking like this: 0, 1, 2, 3, up to so on I plus 1, and the last index is m minus 1. If ith location collision occurs, then we have to traverse to I plus 1. If I plus 1 also collision occurs, you have to traverse I plus 2. Continuous process up to last element, last index. Still collision occurs, then apply wraparound sequence and start searching from 0 followed by 1, 2 like this. Okay? You have to apply the technique in linear probing. Now let us start with the linear probing concept, and they are asking what is the location of 150. Okay? Let me start with first one. So here they provided 45, therefore in the place of k we can substitute 45 here. Okay? Just take h of 45 is equals to 45 mod 12. So 45 mod 12, that is nothing but 9th location, right? So because 45 mod 12 means 36, 45 minus 36, that equals to 9th location. So it is hashing to 9th index of the hash table. 9th index of the hash table. Okay? Your hash table is looking like this. Just observe. Index and then key values. Since they provided hash table size equals 12, therefore index starting from 0 ending with 11. So this is your hash table, friends. Okay? Now first element 45 will be stored into 9th index. So therefore 45 will be stored into 9th index. So remaining values directly I can store there, okay, because we don't have time to discuss each and every value. Now substitute 40 here. 40 mod 12, that is nothing but 4. Therefore it will be stored into 4th index. Next one 98. So 98 mod 12, remainder is equals to 2. Therefore 98 will be stored into 2nd index. Next 60 will be stored into 60 mod 12, that equals 0th index. 36 also will be stored into 0th index, because 36 mod 12 means 0, but 0th location already occupied by key. Then you have to look at immediate free slot, that is first location. So therefore 36 will be stored into first index. Okay. Next 5 mod 12 means 5, it will be stored in 5th index. Next 77. So 77 mod 12, that equals to remainder is 5. It must be stored into 5th index, right? But 5th index already having key value. That's the next immediate slot, free slot we need to look at in linear probing. Therefore this is a free slot, so we can store 75 here, right? 75. Next afterwards 15 mod 12, that equals 3rd index. 28, so 28 mod 12, that equals to 4th index. But 4th index we already having key. Then go to 5th index. Again key is available. Go to 6th index. Again key is available. Go to 7th index. Therefore we can store 28 here. Next 150 mod 12. So 150 mod 12 means is a 6th index, right? But 6th index already having key element. Then go to 7th index. Again key is there. Go to 8th index. That equals 150. Therefore the index which the last record will be inserted is 8th index. That is option D is the correct answer. This question based on linear probing concept. Okay. Yeah. What is the post order of the binary search tree whose pre-order traversal already given? So this is a pre-order traversal they provided. They are asking post order traversal. Remember, whenever they provide alphabetical letters, okay, we need to arrange them in the lexicographic order. Okay, lexicographic order. So in the pre-order traversal, you know, root node is always first node. So here E is a root node. Therefore, we can create E is a root node. Afterwards, in a binary search tree, as I mentioned earlier, left subtree value is always less than or equal to parent, parent always less than or equal to right subtree values. Therefore, if I consider D here, in the alphabetical letter, it is taking ASCII values comparison, friends. Okay, obviously ASCII value of D is less than E, or else you can simply take alphabetical letter A, B, C, D like this. Okay, obviously D must be less than E in ASCII values point of view. Therefore, it should be left side of E. Left side of E. Even though they don't mention, you have to consider their ASCII values and arrange them and consider binary search tree, friends. Okay. Then afterwards A. So A is nothing but here it should be A is left of E and then left of D. Next one B. So B is nothing but here left of E, right, and then left of D and then right of E. Next afterwards C. C is left of E, right, left of D and then right of A and right of B. This is a place where we can insert C. Next one is I. I is right of E. Next one is G. G is right of E and left of I. Next one is F. F is right of I, right of E, and then F left of E, I, and then it is left of G. Next one is H. H obviously right of E and H is left of I and right of G. So this is the way we have to consider binary search tree. Anyway, in the BARC exam they will give complete information about the values also. Okay, it's a mock test just we provided this tree by using the key value CDA like this. Okay. Now what did they ask the question? They are asking to apply post order traversal. So post order traversal is nothing but for every node first you have to process left subtree and then widget and then process right subtree, or else you can apply shortcut method which I explained in the class. Okay. So obviously for every node we are having two pointers, child pointers. If child pointers are not there, they are pointing to null links. Right. So if you traverse the tree, for every node we are touching 3 times. Every node we are touching 3 times. So like it is the first time we are touching, right? So it is the first time. It is first time. Afterwards we are touching second time here. What is shortcut method we discussed in the class notes? The pre-order traversal means when you touch first time you can apply pre-order traversal. You can write in pre-order traversal. When you touch second time you can write in order traversal. When you touch third time you can write in post order traversal. That is a shortcut method which we discussed in the class. Okay. So therefore pre-order traversal means obviously we are touching first time here E, D, A like this. Okay. So obviously they already provide E, D, A. Okay. So that is E, D, A. Afterwards it is second time we are touching, therefore we can start writing in order sequence. Okay. So afterwards we can apply like it is the first time we are touching, therefore we can write in pre-order sequence. It is second time, that is B. First time, that is pre-order traversal. It is second time we are touching, therefore it is in order traversal. Okay. Afterwards it is third time you are touching. So when touching third time you have to write in post order sequence. You have to continue this process, friends. Okay, you have to continue this process. I am explaining directly without wasting time now. Okay, because the time is very important for you. So if you apply post order traversal, obviously you will get C, B, A, and then afterwards D. So C, B, A, D, and then here we are having F, H, G, I. So that is F, H, G, I, and finally you will get E. You can continue this process, you can find the post order traversal, that equals to option A is the correct answer. Okay. So we don't want to discuss complete problem because it's a time based process for you. Okay. Next one. which of the following operations is performed more effectively, more efficiently by doubly linked list than by linear linked list. Okay. If you observe, first operation is deleting a node whose location is given. Next one, searching an unsorted list for the given, it is FOR, for a given item. Third option, inserting a node after the node with a given location. Fourth one, traverse the list to the process of each node. See, they are taking comparison between double linked list and single linked list. If you observe these options, deletion operation is very easy in double linked list when compared to single linked list, because in double linked list we have previous node information, so we can easily traverse the node, right? So therefore, which is more effective means obviously I can say deleting a node whose location is given is the correct answer. So option A is the correct answer. Next one, it is a recursive algorithm based question. They are asking, if it is FO of 5 function is being called from main, how many times FO of function will be called? How many times? So they are asking about number of times FO will be called. If you want, you can solve this one by using recursion tree, or else you can construct recurrence equation. Let me write down recurrence equation. Let it T of n is equals to number of function calls for FO of n. Just I am creating one recurrence equation for finding number of function calls. Okay. Suppose if n value less than 1, automatically control it into operating system. Only one function call is required. Okay. Therefore, T of n value is equals to 1 if n value is less than 1. Suppose if n value is greater than 1, or if n value is greater than or equals to 1, then with this input n we are calling one time. Therefore, I am writing 1 plus. Whenever n value is greater than or equal to 1, with this input n we are calling one time. That's why I had to count it as one function call, right? After one function call, we enter into the remaining part of the program. If FO of n will take number of function calls or T of n, then how many function calls FO of n minus 1 will take? T of n minus 1 function calls. Right, friends, okay? Similarly, FO of n minus 3 will take how many function calls? T of n minus 3 function calls. Therefore, the recurrence equation for this one, whenever n greater than 1, if n value greater than or equal to 1, so FO of n minus 1 will take T of n minus 1, and FO of n minus 3 will take T of n minus 3. That's all. This is the recurrence equation. Now they are asking question is, how many number of function calls are there for FO of 5? So simply substitute n is equal to 5 here. Okay. So for n is equals to 5, T of 5 is equals to 1 plus T of 5 minus 1, that is 4, 5 minus 3, that equals to 2. Right, friends, okay? But do you know what is the value of T of 4? No, we don't know, right? So first you have to compute T of 4 value, okay? So therefore, T of 4 is equals to 1 plus T of, substitute n is equal to 4 here, T of 4 minus 1, that is 3, and 4 minus 3, that equals to 1. So do we know what is T of 3? We don't know. So first compute T of 3. T of 3 is equals to 1 plus T of 3 minus 1, that is 2, 3 minus 3, that equals to 0, right? So still we don't know what is T of 2. So compute for T of 2. T of 2 is equals to 1 plus T of 2 minus 1, 1, and 2 minus 3, that equals to minus 1. Right, friends, okay? And what about T of 1? Still we don't know T of 1. That's why I am substituting T of 1 value also, okay? T of 1 is equals to 1 plus T of 0 plus T of 1 minus 3, that equals to minus 2. Now use the base condition for substituting the values. What is T of 0 value? Just look at here. Whenever n less than 1, we are taking value is equals to 1. So therefore, substitute those values now. So it is 1. T of minus 2 means is also 1. Therefore, 1 plus 1 plus 1, we are getting value is equal to 3. T of 1 value equal to 3, friends. Okay. Substitute T of 1 value, that equals to 3 here. What about T of minus 1? Whenever n less than 1, this value is 1. So whose value is equals to 5. T of 2 equal to 5. Substitute T of 2, that is 5. T of 0, that is 1. So we are having T of 3 is equal to 7. So next T of 3 is 7. T of 1 is equals to, we already evaluated T of 1 equal to 3. So this total value is equals to 11. Okay. Now substitute T of 4 is 11 and T of 2 how much, friends? That is 5. So therefore, this total value is equal to 17. Therefore, number of function calls for this problem is 17. So answer is B is the correct answer, friends. Okay. B is the correct answer. So there is a two-dimensional array and given base address is 351. Given base address is 351. They are asking location of table of 3, 4. Please recall two-dimensional row major ordering formula which we covered in the class. Okay. Just look at here. Suppose if you are having two-dimensional array A of LB1 lower bound suppose you are having B1 to U1 comma B2 to U2. Assume it is two-dimensional array, right, friends? Okay. In this two-dimensional array, if you want to find the location of A of ij, if you want to find location of A of ij by using row major ordering formula, right? So you can just visualize two-dimensional array where starting index is B1 here, means row index is starting from B1 and ending with U1, and it is B2 ending at U2, right, friends? Okay. So we are having elements in this fashion. Assume that there is ith row, which is available here, and there is a jth column which is available at this place, right? Now I want to find ith row jth column element. I want to find ith row jth column element. Then how to find ith row jth column element means first how many rows you completely cross before each ith row. You have to cross I minus B1 rows. Okay. Therefore the formula is looking like this. Base address is denoted by L0, base address plus, okay. How many rows you cross before reaching ith row? I minus B1 rows you completely crossed. I minus B1 rows you completely crossed. Because these many rows you completely crossed, like first row you completely crossed, second row you completely crossed, like that I minus B1 rows you completely crossed. After crossing I minus B1 rows, each row how many elements are there? Each row how many elements are there means number of columns. How to get number of columns? Upper limit minus lower limit plus 1. Therefore, each row we are having U2 minus B2 plus 1. These many elements are there. Number of rows crossed and number of elements in each row. Afterwards, we enter into ith row. Just we enter into ith row. In ith row, how many elements you crossed? In ith row, how many elements you crossed means simply we can say j minus B2 elements you crossed. So therefore, j minus B2 elements we crossed. And each element having particular size. The size of each element I am showing in the form of C. Okay. Therefore, I have to multiply with C. Okay. So there is no space for multiplying C. So just imagine we are multiplying with C. Okay. This total value is multiplying with C. Now in this problem, you can indicate what is B1, what is U1, what is B2, what is U2. Just indicate like this. Okay. So in this problem, it is called B1, it is called U1, B2, U2, where I is equal to 3 and J is equal to 4, friends. 4. What about base address? Base address is L0, that equal 351. What about C? C is the size of each integer, that equal 2 bytes. Substitute all values now, okay. L0 is equals to base address, that equal 351 plus I minus B1, where I indicates 3, B1 indicates 0. Therefore, 3 minus 0 into U2 minus B2 plus 1, 8 minus 0 plus 1, right? U2 minus B2 plus 1, that is 8 minus 0 plus 1 plus J minus B2. J value is 4, whereas B2 value is 0, that is 4 minus 0. Each element size is 2 bytes, therefore you have to multiply with 2, okay. This is nothing but 351 plus, it is 3 into 9, 27 plus 4, that is 31. 31 into 2, that equals 62, right. So which is equals to, this value is 3, 1, that equals to 4. So I think there is small simple mathematical calculation mistake is there. Let me check it once. So 3 into 9, that is 27 plus 4, that equals 31. 31 into 2, that equals 62. So base address they provided is 351. So 351, 410, 413. So we got answers here 407. Actual answer for this one is 407. Maybe somewhere I did calculation mistake. So I minus B1, that is nothing but 3 minus B1, that equals to 0 into U2 minus B2 plus 1. So 8 minus 0 plus 1, 927 plus 1. J minus B2, where B2 equal to 0, 4 minus 0. 3 into 927 plus 4, 31. 31 into 2, 62. So 350 plus 6, that equals to 410. 413 is the correct answer. Let me check the answer for this question. Okay, 413. Yeah, I'll verify this question also once. Okay, next. Yeah, this question is based on if condition. Just look at here. It is not assignment statement, friends. Okay, just look at here. This is not comparison statement. It is assignment statement. They provide A is equal to 0 and B is equals to 10. If A equals to 0, then printf true, else printf false, and finally we have written 0. In this case, they provide A is equals to 0. So initially we are having value of A equals to 0 and value of B equals to 10. Now whenever we take A equal to 0, this is called assigning the value. So make it as assigning value A equal to 0. So computer technology point of view, 0 means false. Therefore, if this condition is false, if it is false, it will not be executed, then else part will be executed. So in the else part we are having false. So therefore option to this question is option B is the correct answer, friends. Okay, option B is the correct answer. Next, in this problem there is a declaration of integer type, but they are using keyword. We cannot take keywords as a variable names. Okay, therefore it is giving compile time error. We cannot take keywords as a variable name, that's why it is giving compile time error, right, friends? Okay, next one. In this program they provided A is equal to 50 and B is equal to 10. Here there is no opening brace and closing brace. There is no opening brace and closing brace. Therefore this is the only one line associated to if condition. It will check the condition 50 less than 10. 50 less than 10 condition false, therefore we can skip this line. Then B equal to B plus 5. What is B here? B equal to 10. So 10 plus 5 means 15. So B value becomes 15, friends. Okay. Now if I ask print A comma B, so A comma B means obviously A equal to 50, B equals to 15. Okay. So answer is A. Next. It is a do while loop. Initially they provided int A equals to 7. Afterwards it is printing A value. First it is printing A value is equals to 7. After A value becomes 7 minus 3, that equal to 4, right? So initially A value is equals to 7. After taking the statement 7 minus 3, that equal to 4, right? So it will check the condition while 4 is non-zero value. Therefore again we have to run do while loop. Okay. So therefore printf A, this time it is printing 4. After printing A is equal to A minus 3, that is 4 minus 3, that equals to 1. 4 minus 3, that equals to 1. Okay. So after taking 1, again it is checking while loop condition. Obviously it is true. Therefore, again you have to execute do while loop. Right. So printf A means it is printing 1. Afterwards A equal to A minus 3, that is 1 minus 3, that equals to minus 2. It means that this while loop condition never get fail. If it never get fail, it is keep on iterating. Therefore, it is taking infinite loop, that is option C is the correct answer for this question. So option C is the correct answer, friends. Okay. Next, in this problem, you need to understand how functional parameters are passing in C programming. In C programming, functional parameters are evaluated from right to left. Right to left. Just look at this program. So there is a ABC function, please excuse me. There is a ABC function and there is a main function. Initially A value is equals to 12. So when we call function, these parameters are evaluated from right to left. Right to left. So first it will take the value of A. Value of A is equal to 12. Afterwards, this post increment operator operating on 12, it becomes 13. Right, friends? Okay. After evaluating right parameter, now it is taking left parameter. Now it is taking plus plus. Plus plus of A means 13 becomes 14. 13 becomes 14. Right? So therefore, it is equals to 14. Now it is calling ABC by passing 14 comma 12. It is passing ABC, that is 14 comma 12. So therefore, X is equals to 14 and Y is equals to 12. After completion of this one, control came back to here, program counter incremented, print A value is equals to 14. Therefore, answer to this question is option A is the correct answer, friends. Okay, option A is the correct answer. Next, what do the following declaration signifies? So simply, whenever you are having multiple parentheses, you always start from innermost parenthesis, friends. Okay, just read like this: X is subscript means array. X is array of 2 pointers. Okay, X is array of 2 pointers means you can imagine there is an X having 2 pointers. Okay, it is X having, there are 2 pointers, X of 0 and X of 1. Each pointer point into a function, means there is a function. Assume that there is a function f. There is a function f. So every pointer is pointing to that function. Okay, you know that every function name always holding base address of the function. Therefore, first pointer is pointing to function f, and second pointer also pointing to function f, where that function is written a pointer. Okay, so it is giving one pointer where that pointer is pointing to array of this pointer, whatever pointer it is returning, that pointer is pointing to array of 6 integers or array of 6 characters. Okay, so therefore answer this question is X is array of 2 pointers to function, where function returning a pointer to an array of 6 characters. Okay, so these are the questions based on programming, algorithm and data structures. Okay, give me 1 minute time, I will check this question once. Yes. So here we are having, there is simple mathematical calculation mistake is there here, that is, it is number of elements crossed, right? So number of elements I crossed here, that is U2 minus B2 plus 1, that is 8 minus 0 plus 1 elements you crossed here. It means that we are having 9 elements you cross in each row. Okay, so therefore this explanation is correct, that is 413 is the correct answer. There is no correct answer is matching here, so option C is only correct, that is 413 friends. Okay, by mistake they mentioned it is 407, so 413 only correct, so there is no mistake in the explanation. Okay, next my colleague will continue the class. Okay, thank you.
Yes, dear students, very good evening. Now it's the time for the digital logic. First question, very simple question. We have the technique, and also if you go for the regular method, easy method here. Let us 64 to the base 10 and minus 64 to the base 10. This question is 64 to the base 10 minus 64 to the base 10 minus 64 to the base 10. Now, so first of all, 64 convert into binary here, 64 number. First I will teach the regular method, then we will go for shortcut technique here. 2. Now 32 0, 2 16 0, 2 8 0, 2 4 comma 0, 2 2 0, now 2 1 0. So 64 we can write, 64 number we can write it as a, yes, I am writing the 64 number. 64 to the base 10 equal to 1. How many zeros here? 1, 2, 3, 4, 5, 6 zeros here. 1, 2, 3, 4, 5, 6 zeros here. This is called as unsigned number. This number is called as unsigned number, but examiner is asking the signed number, signed complement number. So same number I am writing, same color here, 64 to the base 10 equal to same 1, 2, 3, 4, 5, 6 zeros here, but plus 64, plus 64. Because of white color plus symbol, so I am placing the MSB bit should be 0 here. For positive number, MSB should be 0 plus symbol. So number of bits is required. Count your number of bits is required 1, 2, 3, 4, 5, 6, 7, 8 here. So for positive number, n equal 8 bits here. Examiner is asking number of bits here. First option should be 8 is correct answer. First one should be 8 is correct answer. So no doubt option A and option D are wrong answers here. Option A and D are wrong answers. Next for negative numbers. So negative number what we need to write 64 to the base 10 minus here minus, but which complement is asking? Use the 2's complement here. Clearly in the question paper 2's complement. For the 2's complement simple shortcut technique here. 2's complement shortcut technique here. Up to 1 write as it is here. Up to 1 write as it is here. Up to 1, up to first non-zero digit write as it is. Remaining bit is a complement. Remaining bit is complement means 1 here. But according to sign extension, whenever same number of bits are there, same number of bits means so we can neglect the MSB bit here. Keep only one bit here. Keep only one bit. Now when for negative number you can place many number of ones, many number of ones. You can remove also. So after removing the same equivalent equal to 1 0 0 0 0 0 0 here. Okay. So number of bits required for negative number equal to 7 bits here. 7 bits here. 7 bits here. Okay. So correct answer minimum number of bits. Minimum number of bits means we can remove this MSB bit. So 1007 is correct answer. 7 is correct answer. 8, 7. So obviously option C is correct answer. Option C is correct answer. Whenever a number is expressed in 2 powers, 2 power 6, a number is expressed in 2 powers means so positive number, negative numbers are not equal. That is shortcut technique. Positive number, negative numbers are not equal. Equal means wrong answer. Equal means wrong answer. And wherever the equal number is wrong answer. And positive number, one bit is greater than negative number. Okay. This is the suitable answer here. Okay. You can go this method. This is the first question. And second question here is also min term is given. Examiner is asking max term here. First of all, examiner is given in the SSOP. Examiner was given question in the SSOP. Question is asking in SPOS format is asking. SPOS format is asking. So this is a given variable. Convert into max term format. Max term capital M dear. Capital M. Missing terms here. Only 3 variables are there. X, Y, Z, X, Y, Z. So 3 variables means starting from 0, missing variable 1, 2, 3 and 4. Okay, 0, 3, 4. 0, 3, 4 means how to write here this 0 represent in 3 bits 0, 0, 0 and 3 as 0, 1, 1. 4 is a 1, 0, 0. How to write this answer here? How to write this answer here? Now x, y, z, no? F of x, y, z, x, y, z, x, y, z. Now we can write this answer as a x plus y plus z here. X plus y plus z here. Observe. X plus y plus z here. Why? Because 0 means variable. Here in SPOS format, the format here 0 means directly write the variable. 0 means directly write the variable here. Wherever 1 means complement you outright. Complement you outright. 1 means complement you outright. So here next to 1 0 x. 1 means complement. Second y bar plus z bar. Product of 1. 1 means complement here. X bar plus y plus z here. So what is the best suitable answer here? It is SPOS format. What is the best suitable answer here? Now option D is correct answer. Observe x plus y plus z, x plus y bar plus z bar, x plus y bar plus z bar, x bar plus y plus z. Option D is correct answer. This is the second question. Now from the digital, one more interesting question here. Observe. Consider the following. Examiner is given in SOP form is given, is asking question in the POS form, but it's not easy. What is the method is given SOP form? We need to convert into SSOP form first. After SSOP form, convert into SPOS form. Okay, after SPOS form, then convert into POS form by using K-map here. Using K-map, guys. Using K-map here. So first, our step is SOP to SSOP. SOP to SSOP. How to convert SOP to SSOP here? Given question here, F equal to A bar. Here in this one, BCD is missing. BCD is missing. So B bar plus B I am writing. Okay. Otherwise, okay, B bar plus B. Just wait a moment. Now F equal, what is the given here? F equal to now given question F equal to A bar. Here BCD is missing. Missing variable I am writing 1. 1 BCD. 1 I am writing. If I write 1 also no effect on the result. Now next A C bar. A C bar means second one. A C bar means B is missing. B is missing plus 1. C bar. D is missing. Next A bar B bar C plus A bar B bar C. D is missing. So missing I am writing 1. Next to A B C bar D. All are present. A B C bar D plus A B C D. A B C D. All are present. Okay, no problem. Now later what we have tried, wherever missing here, missing variable B family is missing, so B bar plus B you can write. Next to C family is missing, C bar plus C you can write. Next to D family is missing, D bar plus D you can write. This is a one term plus A. Here 1 B family is missing, so B bar plus B guys. Now next to C bar is present. Yes, D bar plus D here. Next one A B C. A bar B bar C. Here D is missing, so D bar plus D, correct. Now A B C bar D plus A B C D here. Now in this one it is a no doubt it is a SPOS format, SSOP format. In SSOP format what we have to do? In SSOP format, wherever the variable here, variable is place 1 here. Wherever the variable is place 1, complement of variables, complements we have to place the 0 guys. Yes, 0 dear students. Now here after placing here, now we'll get the F equal to in SSOP format sigma m of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13. Yes, 12, 13, now 15 years. This is a sigma m format, So sigma m missing is pi m term, 10, 11, 14. So I am writing here, this side only, I am writing. So SSOP format, sigma m of 0, 1, 2, 3, 4, 5, 6, 7, 8. Now 9, 12, 13, 15 here. Missing of these terms is called as a SPOS format. Here now I have written SPOS format here. So take the 4 variable K-map here, 4 variable K-map, it is a 4 variable K-map. Now wherever the missing here are 10, now present here, max terms is 10, so place 0 here. Now 11 present, 11, next to 14 here. Now group here, the grouping method here, by grouping we can group this to one pair is possible. Okay, very good. Now next one more pair is possible here. This is one more pair is possible. Now write this answer. After writing this answer, now no doubt this red color answer observe. Here for this one, what is a common here? A is same 1 1. So 1 1 in SSOP form, SPOS format A complement plus A complement. In this one for red color observe. Here C is 1. C is 1. So C complement here. Now D is 0. 0 means directly variable is present. So A complement C complement plus D. Now coming to this yellow color group, observe yellow color group here. This entire box here, observe A is 1, A is 1. So whenever 1 means complement will get in the SPOS format. B is 0, B is 0 means directly variable will get. Very good. Now next one for this two group, here C is 1, C is 1. So C complement here. So C complement here. So best suitable answer here, observe best suitable answer here. Now no doubt option A is correct answer. For this question option A is correct answer. This is a given SOP, examiner is asking POS format, the simple, okay, this is a formula. Now we'll observe one more question here. Simple, very basic question. Now, okay, a very simple question here. Examiner is asking A minus B here. Perform the subtraction A minus B. So whenever large minus small, so answer is the original format, answer in original format, correct. But this is not a question, What is the question here? Small minus large, whenever subtract small minus large, result in the 2's complement format here, result answer is in the complement format. So read the question here. Question belongs to the case 2 here, small minus large. So result available in the 2's complement format, option B is correct answer. Next, Ripple counter. Ripple counter means one more question. It is asynchronous counter, guys. Asynchronous, dear students, it is asynchronous counter. Asynchronous counter here. Synchronous counter. Synchronous counter whether 4-bit or 1000-bit also. For synchronous counter, now I am writing first, second case. For synchronous counter. For ripple counter, total time equal to the, okay, ripple counter, the delay equal to n product of 1 TPD. N equal 4 here, n equal 4, and one more is the delay is given. What is that? Is delay is given 10 nanosecond. So here 4 into 10 nanoseconds, so 40 nanoseconds is correct answer. 40 nanosecond is correct answer. 40 means 10 is wrong answer. 10 is wrong answer. 30 also wrong answer. So only one option is okay. R. For synchronous counter, the delay is even 1000 bits also. Simple TPD only. So that is a 10 nanosecond is correct answer. Even 1000 bit also. So the best suitable answer is option B is right answer. Now this is a designing by using off adders. Examiner is asking design this expression by using off adders. How many off adders are required? So first we'll design. Now here let us. I am taking one off adder here. This is off adder. First of all, we require the minimum basics. The basics here. What are the basics here? The basics here. Now here, what are the basics here? Off adders here. First of all, off adder equal to. Let us take the now x, y. There are two inputs here. Now you will get the two outputs here. One is the two outputs here. X, XR, Y. Sum and carry is a product of these two. What are these two numbers are there? Exclusive OR gate, one output, and AND gate, one output here. One is XR gate. XR gate output is one, and AND gate is one output here. These are the off adder basics here. These are the off adder basics. So you can arrange any inputs. You need to produce these expressions here, derive this expression. Let us, I am taking AB, guys. Yes, AB. This is off adder 1, sir. Yes, dear students, off adder 1. So what is the answer you are getting here? No doubt A XOR B. One more output you will get. That is nothing but product of these two. That is the product of these two, AB. What are the inputs here? One is exclusive OR gate, one is AND gate. Okay. Till now we did not derive any expression here. You can take the another different color I am taking. This is a one more different color here. One more off adder. Second off adder here. So join this one, and one more input apply. One more input you can apply here. This C input here. If you apply the C input, what is the output you will get? This input XOR with this input. Now A XOR B XOR C. This expression is nothing but what? A XOR B XOR is nothing but what? E, guys. Hello dear students. E expression. We have derived E here. Okay, happy. One is completed, but remaining two expressions. One is XOR gate, A XOR B XOR C. One more input is product of these two. Product of these two is what? Product of these two. Now this one product of this one. So I am writing A XOR B product of C. Guys. So what is the answer we can write? A complement B product of C. A B complement product of C. Any expression is there? A complement BC, A B C. Okay, good. Expression D is also. So we have derived expression D also. Out of 3 expression, 2 expression completed. Next we have to design F also. F means by using 2 off adders it is not possible here. By using 2 off adders it is not possible. One is impossible. By using 2 also not possible. Take the 3, one more here. I am taking one more, guys, here. Yes, dear friends, one more I am taking. Off adder 3. So yes, this input I am applying. Here. Okay, this input I am applying. You can design anyway. So this input XOR with this input. Yes, exclusive OR gate. AB XOR with C. That is nothing but what? AB product of C bar. This one normal complement. Next to AB complement product of C. Help me here. ABC complement. AB whole bar by using De Morgan's law. A complement plus B complement. A complement C plus B complement C. That is nothing but what? Come on, tell me. F expression. That is nothing but F. So to derive this one, this 3 expression, how many minimum number of operators required? The best suitable answer is 3, guys. Yes, dear students, 3. Now, little bit practice is required. This one, lot of command over we required. Lot of command over the operators is required. Then you will get the answer. Yes, we have one more question here. One more question here. Very simple question. Yes. In the digital 3 input majority gate is given. M, A, B, C is given. So here M given. Examiner was given. This is a given. But is asking what? M, A bar, B bar, C bar. First of all, this is a question here. This is a question. Now I am writing M of A bar, B bar, C bar. So wherever the A is there, all are complement only. A complement, B complement, plus B complement, C complement, plus C complement, A complement. Very good. This is the equation number 1. Let us equation number 1 here. Equation number 1. This total is equation number 1. Now, second is what? A, B, C complement. Wherever the C is there, only C complement here. Yes, in digital, one more question here. A, B, C complement. Same in this expression. Wherever the C is there, just to C, write down complement here. C complement A. This is the second expression. Second expression. Total second expression. Now coming to the third expression here. Third expression. M of, oh, third one only C is there. Happy. Not required. Happy. C only. So overall I am writing, given question here. Overall I am writing M of, this total expression is nothing but, this total expression is, this is the equation number 1. This is equation number 2, guys. This is a 1, equation number 1, equation number 2, then C. 1, 2, 3 means what we can write? Come on, tell me. 1 into 2 plus 2 into 3. 3 is nothing but C plus third one C product of 1. After product of all this one, what is the expression you will get? After multiplying all this expression, substitute here 1, 2, 3. So no doubt you will get the ABC plus ABC plus ABC plus ABC. Simple, we discussed in the classroom. Leave A, remaining 2 component, leave B, leave C, leave all. This is nothing but A XOR B XOR C, guys. So that is nothing but 3 input exclusive OR gate. 3 input exclusive OR gate. So what is the best suitable answer here? Observe. The best suitable answer is a 3 input exclusive OR gate here. This is a 3 input exclusive OR gate. Option B is the correct answer. So these are the questions from the digital logic.
Hi students, let us discuss the questions from our discrete mathematics. My dear, we got some 10 questions from discrete mathematics. Yeah, just to see this, there is a question from logic. So the given formula is V is equals to, there exists some x, A of x, which implies B of x, and W is equals to, for all x, A of x, which implies there exists some x, B of x. These two formulas are given. And what they are asking is, which of the following is true? So coming to the options, they ask like this: V implies W, or W is logically implies V, or in some options they given that one is valid, one is not valid. Some different options are available like this. Yes, my dear, see this given formula. The given formula is what we have here. The given formula V is, there exists some x if A of x is true, which implies B of x. Yes, my dear, this is the given formula. And if you observe something called implication, we know about implies rule. What implies rule says, if we have P implies Q, we can take it as negation P or Q. Let us use this conditional rule or implication rule, you can say, which is equivalent to there exists some x. Now here A of x is acting like P and B of x is acting like Q. P implies Q can be write as negation P or Q. Negation of A of x you can get, or B of x we can take. Now let us apply the their existential quantifier here, and which is equivalent to there exists some x, negation of A of x, or there exists some x, B of x, like this. Now see this, now I am here at just like RHS part, not P or Q we have. From not P or Q, let me write P implies Q. So, my dear, this is not P. From this not P, I am writing P here. If it is negation P means the P comes to negation to their existential, it will become for all x, and this is A of x. Yes, my dear, this is negation P, then it will become as P. I hope the point is clear. And which implies there exists some x, B of x, like this. Okay, this is the formula we got. My dear, if you observe this formula, this formula is exactly equivalent to W, right? For every x, if A of x is true, then there exists some x, B of x is true. Let me say like this, which is equivalent to W. Now in this case, what we can say is, yeah, V implies W is possible and W implies V is also possible. Yes, my dear, V is logically implied to W, W is logically implied V, which means that the formula V and W both are logically equivalent. That is the answer to this question. Now see this problem. And here we have a undirected graph with vertex set of 1, 2, 3, 4. 1, 2, 3, 4 vertices are available. And what is the minimum possible weight? My dear, the given graph is a weighted graph from vertex 2 to vertex 3 such that P contains at least 2 edges. Right? Minimum 2 edges you need to take. and we required a path from vertex 2 to, what do you say, vertex 3. Yeah, vertex 2 here, I want to take the paths in this way. Vertex 2 here, let us take 2 to 4, 2 to 4 which is of 4 units, and 4 to 1, 4 to 1 of 1 unit, and 1 to 3 that is of 8 units. My dear, if you take this path, yeah, we are following the condition. The path consists 3 edges. We just required 2 edges here. Path is nothing but set of edges. What do you say? So 4 plus 1, 5, 5 plus 8, 13. The path cost comes to 13 units here. So this is the first path we have taken, and let us take the second path. Now let me move on in this way. I want to take the vertex 2 here, 2 to 1, that is of 1 unit, 1 to 4, that is of 1 unit, and 4 to 7, 4 to 3, that is 7 units. Now here the path cost comes to 1 plus 1, 2 units, 2 plus 3 is 7, 2 plus 7 is 9 units. My dear, we got the path which is of cost 9 units, and moreover in the options 9 is the minimum number. You may thought like there is a option C which is of 8 units, but you try in any way, you cannot get 8 units at all. The minimum possible weight is 9 units, my dear. Appropriate answer is 9 units. Now let's see this problem. There is a question like from the propositional logic. They given one formula and they are asking about either it is tautology or contradiction or contingency, or maybe the given formula is valid but not satisfiable. I think that option D is simply meaningless. The formula is valid in the sense always true, but not satisfiable. Not even one time is not true, right? You can say something like this. You can say like it is satisfiable but not valid. That is okay. But anyway, let us see the given formula. The given formula is not P, which implies Q implies not W. That is the first premises we have. Yes, my dear, here I am taking the direct proof method. Yeah, here I am going to take step number here, and actual step I am taking, and what's the reason for that step. So if you take the steps here, the first premises comes to negation P implies Q implies not W. And the second premises is not S, which implies Q. And the third step is negation of W implies T. And the fourth premises is not P or T. Yeah, so whatever the 4 steps I am taking, all these steps reasons are same because they are the given premises here. Yeah, let me do some modification here. My dear, if you observe the step 2, not S which implies Q, here I think you can write it as SRQ like this. Yeah, if you want to simplify this one comes to negation of W which becomes as W, and this is and what do you say? This is negation T. Right? So here I have taken implication law and also I have taken De Morgan's law. Both laws I just applied and it is modified like this, W and not T like. So not P or T, I can write it as P implies T, just to keep it like this. Now let us proceed. What we can take is, I want to take from the step number 3, by the rule of conjunction, conjunctive simplification. What we can write? We can write like this. W and not T, we can take it as W. And not T also I can take. This is also same from step 3 and the reason is conjunctive simplification. And here we have W and here we have and T. What I want to do is, I want to apply step number 4 and step number 6. Yes, I am applying what do you call rule of disjunction. Yeah, if I take negation T here, then negation P has to be true. Negation P has to be true here. So this is possible from step number 4 and step number 6 by rule of disjunction, or you can say disjunctive syllogism. We have taken in that way. And after that negation P, if you take the negation P with the first one, so this is 1 and this is 7, by the proof of direct from 1 and 7, by the rule of modus ponens, what we can get? If not P is true, the result comes to Q implies negation W. My dear, Q implies negation W is available here and W is true. So let me apply 5 and 8. Yes, 9th one. Yes, I want to take here like this. By the second rule and the 9th rule, so if you apply Q is true here, Q is true here, or you can watch SRQ, that is also no issue at all. If you want to take this area, you can mention modus tollens, or if you want to apply SRQ like this, that is rule of disjunction you can say. Yeah, it comes to something like Q here. And also not only about this one, you can also apply in this pattern also, negation P or Q, this is available and T is available. From this T also you can take. So in any way you can apply and the result comes to what do you call negation yes. Negation of negation yes, that will become yes. Yeah, thus S is the valid conclusion like this. My dear, the point what you should observe is, not only these rules, you can apply another rules also. You can go with another rules also, but you can get the answer. For example, some student is there, what he will do? He will do like this. He want to take negation yes implies Q here, and he want to take Q implies negation W here. Let me write here, let me write. So it is just like negation yes which implies Q, this rule, and Q implies negation W. Now from this he can make it by the rule of hypothetical, he can take it as negation S implies negation W. And after that, he can go for W. What is W? W is true from the rule 5. So you can take from step number 5, W. Again, you can apply modus tollens. So W is true, then negation W is going to be false. Then negation of negation yes must be true. By the rule of modus tollens, you can conclude that answer is like this, right? This is one way, what do you call, by using the direct proof you can solve the question. And I can also show the indirect proof to solve the same question. Just understand the given scenario, that is just like this. Negation P, which implies Q implies not W. And after that, not S, which implies Q. Negation of W implies T. And negation P or T. This totally implies that, yes. My dear, what you should understand is, if the given argument is not valid, then the conjunction of the premises, they can lead to a false conclusion. If it is a valid, what should be happen? P1 and P2 and P3 and P4, which implies some conclusion that should be true. So, if individually all these conjunction of the premises is true, then definitely the conclusion must be true. That's a valid conclusion. But I am going indirect proof. What I am going to do is, I want to consider the conclusion is false. If the given formula is not logically valid, then this case does not exist. Even if you want to try for this case also, our objective is, we want to make this P1 is true. This second premises P2 is true. And this third premises P3 is true. And the fourth premises P4 is true. Then the result conclusion should be false. You try for that case, but that case does not exist. Either it is really possible or not, let us check. I want to begin with the conclusion is false here. If the conclusion yes is false, then not yes must be true. If not yes must be true, then P has to be true. P should not be false, right? Yeah. What I have taken not yes and Q. So there is no impact on W and T. Let us make this. I want to make this area too. I think negation is there totally for entire formula here. Yes, negation is there for negation of W comma T here. Yeah, negation of W comma T here. If this is true and if it is false, then total negation becomes negation of false, that will become as true. Now see the impact. Negation of W. W is what here? So here W is true, then negation W should be false. And Q is true here. My dear, this area is already false, then this should not be true, this must be false. Yeah, just now see. I successfully made the second premises true, and I also made the third premises also true, just by consideration whatever it is. I made the first premises also true. P1 is true and P2 is true and P3 is true. But coming to P4, what happens is, negation P in this situation, this is false. And T, where is T? Yeah, T is here. T is also false. False or false, the final result false, my dear. So the result comes to true, true and false. If one thing is false, then the conjunction of the premises becomes false. So what we can conclude in a single idea, when the conclusion is false, then you cannot make the conjunction of the premises as true, as the given argument is a valid argument. If the given argument is not valid, you can make it. You can make the conclusion false, and this area is true. I tried for that case. when that is false, this can be true, but I am unable to make it. The conjunction of the premises becomes false. So when the conclusion is false, the conjunction of the becomes false, then the total argument is tautology. It is always true. In the class we discussed it like this. If today is Sunday, then it is holiday. That is the valid argument. In that case, if you consider if today is not holiday, then you can confirm today is not Sunday. Right? Both direct proof and indirect proof, both I touched here. And see this question. There is a question from recurrence relation and options are available. My dear, I can do this in a shortcut manner. In the first option an, 10 into 4 power n minus 3n plus 6 2 power n, that is the available solution. So when do you say that the solution is the solution to the recurrence relation? If it is really a correct solution, the solution has to satisfy the given relation. The first term, second term, third term, every term it has to be come from that solution, then only you can call it as a complete solution or general solution or a solution with a complementary function plus a particular solution. Now in this scenario, what can I say is, you just see option B. In option B, I have an is equals to something. In the problem, initial condition A0 value is 4. Let me check this. If I take A0 here, 7 into 4 power 0, 3 into 0 plus 4, 2 power 0. In the real number sequence of the recurrence relation, I have taken n is equals to 0. Then answer comes to, this is something like 7 into 1 and this area is 4. The result comes to 11. My dear, what can I say is, if you put n is equals to 0, you are not getting the initial term. The initial term A0 is 4 here, but I got 11. I hope you observed that. So next let me take the something like second term, option C. A0 is equals to 8 into 4 power 0 plus 2 into 0 plus 3 and 2 power 0 like this. This comes to 8 plus 3. Yeah, this is also 11. And coming to D, 5 into 4 power 0 minus 2 into 0 plus 6, 2 power 0. So this is value comes to 5 and I think this is minus 6, some minus 1 we got. All the options B, C, D, no option is matched with the initial condition. Let me check with the first option, that is option A. If I go with option A, A0 is equals to 10 into 4 power 0 minus of 6 here and 2 power 0. And here it comes to 10 into 1 minus of 6 into 1. 10 minus 6, that is equals to 4. My dear, just observe this. Here A0 value comes to 4. No other option is matched with this. In this particular question, just by using this shortcut, you can confirm the answer. I know you can take the characteristic equation and you can solve the recurrence relation by taking the f of n function, phi of e value and the substitution method. All these are possible, I agree with you. But in competitive spirit, when the options are available, I think this is more than enough. That's why I am not going to the general process. I hope you got my point. Now see this. Here we have a simple connected graph with 10 vertices, no cycle of odd length, and the number of edges in the graph lie between. So they are asking about the range of the edges, my dear, in the graph. So if you see this, the first point what you should notice is the given graph is a simple graph, and moreover it is meant by connected. What is meant by connected graph, my dear? So connected graph in the sense there is a path exists between every pair of vertices. Yeah, definitely there is a path exists. You can take any pair of vertices, either in our discrete or data structures, you know that. It doesn't mean that there is a direct edge, which means that the path exists, that's all. And another thing is, in the given graph, there is no cycle. There is a no cycle of odd length. When you are saying that there is no cycle of odd length, which means that the graph is going to be a bipartite graph. You are not only just listening to this, just to focus on the points. Here I said that path exists, and here I said that it is a bipartite graph. How the both conditions can be possible? Just to visualize yourself. The path has to be exist in every pair and also bipartite. My dear, visualize. If there are 10 vertices with you, the possibility comes to in this way. Sometimes in worst case, only one vertex available. 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices are available. And every vertex is going to be connected to this. This is one possible bipartite graph. And other possible bipartite graph, you can think like 2, 3 other things I can agree. Let us go for maximum case. Sir, this is nothing but a tree. A tree with 10 vertices and 9 edges. N vertices and n minus 1 edges. The minimum possible number of edges comes to n minus 1. That is nothing but 9. This is min range. Maybe in examination, if you watch this 9, you can select some options and you can eliminate some options, selection by elimination. And let us think like bipartite graph with maximum possibility. Sir, just take number of vertices comes to 10 and you can partition. Just to focus on the word partition refers to possibility comes to 5 by 5. So on this 5 you can make 5C2, on this 5 you can make 5C2, 5 into 5, 25 edges are possible. Without formula, conceptually you can do like this. But if you are interested in formula, let me say like this. It is nothing but floor value of n square by 4 in case of bipartition. That is nothing but floor value of 10 square by 4. That is 100 by 4, 25. The graph is a connected graph and moreover bipartite graph. Min range is 3, max range is 25. So the range comes to, can I conclude the answer like this? 9 and 25. That is the answer to this question, my dear. Now see this. We got another problem from graph. Let G be a simple connected graph with n vertices on which with adjacency relation is transitive. Whenever there is a edge UV and edge VW, definitely there is a edge from U to W. My dear, we examined this many times in the classroom also. Many times I told the example like this. The brother relation is transitive. If Salman is the brother of Shah Rukh, if Shah Rukh is the brother of Abhishek, then Salman can also be the brother of Abhishek. The same thing they just connected with a graph. If a vertex U is adjacent to V and a vertex V is adjacent to W, and then U is also adjacent, U is also neighbor to W. This is the meaning of this word. Transitive property is holds good with adjacency. Now in this scenario, what you have to understand, the given graph is a connected graph. Connected in the sense, the path exists between every pair of vertices. Are you visualizing that? A is adjacent to B, B is adjacent to C. Then A and C are also adjacent. One more thing, C is adjacent to D, then BD are also adjacent. Then AD are also adjacent. I hope you are visualizing the picture. The picture comes to a complete graph. Then the graph G is going to be a complete graph on n vertices. If it is a complete graph Kn, then the number of edges comes to NC2. NC2 is n into n minus 1 by 2. Maximum possible connections, my dear, just like mesh topology in our computer network. How do you say every device is connected to every other device? They have the direct link. In the same way, NC2 answer comes to like this, n into n minus 1 by 2. C is the correct answer to this question. Is it okay? Now see this problem. Here we have a function f of AB, and f of AB consists a plus b, a minus b, and they are asking about 1, 1 and on to all these things. Yes, my dear, let us make it. Given f of AB is equals to, on this Cartesian product, a plus b, a minus b. The domain is a Cartesian product. Yes, codomain is also Cartesian product. R cross R it is. Now let me begin with 1, 1. I want to begin 1, 1 discussion with, let me take the images are equal. Let us suppose the images f of AB and f of CD are equal. My dear, I am writing f here, images are equal. F of AB in the sense you can get a plus b, a minus b here, and f of CD become as c plus d, c minus d here. So this is a order pair, first coordinate and second coordinate must be equal. You can get a plus b is equals to c, and you can also get a minus b is equals, this is c plus d, and a minus b is equals to c minus d like this. My dear, you can just add these two equations, or you can also subtract these two equations. If you add these two equations, you can get a is equals to c, and if you subtract it, you can get b is equals to d. If these two things are happen, then only this equation can be possible, which indirectly means that what I am trying to convey is a plus b, AB order pair should be same as CD. If I take order pair AB, which is same as CD. And what you can say here, I started the discussion with images are equal and I got elements are equal. If images are equal, elements are equal means it is 1, 1 function. And let me discuss about onto. Let us take an image f of AB which is equals to the order pair of CD. What is f of AB can be? It is like a plus b, a minus b, which is equals to c comma d. Let us equate the order pairs. A plus b is equals to c and a minus b is equals to d. I can add this equation and I can subtract this equation. If I add it, I got 2a is equals to c plus d and a is equals to c plus d by 2. Can I write the answer directly? And in similar way, if I subtract it, I can get 2b value and b is equals to c minus d by 2. If I take AB here, for this AB, I got the images like this. Now what I started here I got something like this. f of AB is equals to CD. F of AB in the sense, A in the sense, C plus D by 2, B in the sense, C minus D by 2, and which is equals to C comma D. My dear, don't forget the theme of the question. R cross R, that is nothing but the real numbers. I started with real numbers. I just imagine there is a image exist, and I got C plus D by 2 and C minus D by 2. So you just visualize the mapping picture. So this is domain here and this is codomain here. If you take any element in codomain CD, definitely there exists a pre-image in the domain. That image name is, pre-image name is C plus D by 2, C minus D by 2. Yeah, if CD are real numbers, C plus D by 2, C minus D by 2 is also real number. So what I am saying here, every element in the codomain definitely will have the pre-image in domain, which means that it is onto function or surjective function. So you are going to conclude the answer like this. Yes, F is also onto. Yes, F is one function and F is onto function. Let me conclude the answer in this way. F is a bijective function. That the answer to that question with clear-cut example. You can choose just elements. Instead of elements, if you solve the problem with AB, then nobody can question you. That is a generalized process. Yeah, got it, my dear. See this question. And here we have a question like D30, the set of all positive divisors of 30 here, and they are asking about distributive, complemented and complement of some element, and they are also asking about poset. Yeah, shall we discuss this? Yeah, here we have D30. D30 means divisors of 30. Divisors of 30 in the sense 1, 2, 3 here, 5, 6, and also we have 15 and 30. So operation is relation here. The relation is divides. If you take divides process here, the first element comes to 1. This is 1. And we also have 2, 3, 2, 3, and 5. The relation is divide, so that's why I am taking 2, 3, 5 primes individually. 2 doesn't divides 3, so there is no relation between 2, 3, or the same discussion for 2, 5 also. And the next element is 6 here, 15, 6 here, 15, and we also have 10. Let me take one more element, 10 here. And the upper bound of the element is 30. Yeah, 6 divides 30, 10 divides 30, 15 divides 30, and all the factors of 15 also divides. And this is the structure you got. My dear, if you see this structure, what happens here? Let me take some element like 2. The maximal element is 30 and the minimal element is 2 here. If I operate 2 and 6, 2 join 6 becomes 6. And 2, 3 if I take, 2 join 3 is 6. So what do you say? 2, 3 are not complements. And even 2, 5 are also not complements. And 2, 15, if you observe 2 and 15, 2 join 15 is equals to 30 and 2 meet 15 is equals to 1. So you are getting maximal element here, minimal element here. So which means the complements of element 2 is 15. Yeah, can you guess what is the complement of 3? 3 complement becomes as 10. 5 complement become as 6. 1 complement become as 30. What you are understanding from my words? So every element is having complement, and moreover that complement is exactly once. Only one complement, not more than one complement. I am following the rule of distributive. Every element is having at most one complement, and I am also following the rule of complemented. Every element is having at least one complement. At least one complement, at most one complement, and every element is having exactly one complement. From this Poisson diagram, you can solve the question and you can confirm the answer like this. Yes, sir. It is a distributive lattice, it is a complemented lattice, and the complement of element 2 is equals to 5. Clearly I written here, their join gives maximal, their meet gives 1, complement of 2 is 15. All 3 options can be true, my dear. And coming to the fourth one, the total order cannot be possible because the structure is available in front of you. I just ask you a question, what is the relation between 2, 3? 2 doesn't divides 3, 3 doesn't divides 2. There is no relation between 2, 3, which means that 2, 3 are not comparable. If 2 elements are not comparable, you can simply say that that structure cannot be total order. You may say many other examples. I think one failure example is enough. I already given just like 2, 3. This is the first level of solving the question, my dear. And I will also tell you one point. Let me solve the question in second style. The given structure is D30 and the operation is divides. If you take the element 30, 30 is nothing but 2 into 3 into 5. It's a product of primes. It's a product of primes, and moreover it's a square free number. No number is a perfect square here. If no number is a perfect square here, I told you many times in the class, there is a direct shortcut for Dn. So the Dn with operation, relation, something called divides, it is going to be Boolean structure directly. D30 with relation 1 is going to be Boolean structure. When I use the word Boolean structure, you should understand that it is distributive lattice, first point covered, it is complemented lattice. You may have some doubt about third one, just wait a second. In Dn, if it is a distributive lattice, if you want to find out the complement for any element like x, that x is nothing but n by 2. Right? It is nothing but n by 2, you can say. Yeah, just like, n by x like. I think like n by x. For example, if you want to ask me the complement of 2, 2's complement is 30 by 2, it's become 15. Let me verify one more time. If I want to find the complement 5, yes, it is 30 by 5 and it is 6. My dear, just leave this. Just understand this part. Complement of x is n by x. Complement of 2 is 30 by 2, that is 15. I also covered the third statement, my dear, here. This is also true. So which of the following cannot be the true in the sense, your answer comes to this one. It cannot be total order, and all the remaining options A, B, C can be true. So if it is not true, you can choose the option like D. And I given Poset lattice diagram, Hussey diagram clearly, and I solved the question with complement normal formula, and I also told you the shortcut. My dear, there are many ways to solve the problem. Different approaches are correct. Without violating the rules of lattices, each and every process can be correct. Okay, that is some discussion about our discrete. Thank you.
Hello students, welcome to ACE Engineering Academy and ACE Online, and myself Ramesh Masuna. I am going to teach the DBMS questions. Here the first question given is, convert the following alternatives to ER model. From ER model, convert them to relational model. Then which of the following alternatives will have only two relations? It means number of tables to be 2. Just recollect the point, when the number of tables to be 2, if the relation participate with 1 to many, or if the relationship participate with many to 1, or if the relation is participating with 1 to 1. So means except many to many, in all the other 3 cases there are 2 tables possible. Right. The first one, a customer has many accounts. So means cardinality I am writing, many accounts, and an account can be owned by one customer or more. So it is many. Now cardinality is many, so it could be not be the answer. And option B, a supplier supplies many parts, and a part can be supplied by many suppliers. Again here the cardinality is many, so B is not the answer. And C, a person can have many loans and a loan is owned by only one person. Means what cardinality it is showing? 1 to many. So answer for this question is option C, because cardinality is 1 to many, it can be represented with only 2 relations. Now the second question, given functional dependencies, then which of the below one is false? Here the dependencies are given, which dependency is false. How do you check which dependency is correct or false? By taking the closure of left hand side to see right hand side is possible or not. Take the closure of A closure is AD, right? A closure is AD, with A we have B possible, with B we have C possible, with C we have M and N possible. What is expecting with A, B and D, both are possible? This is true, because question is false, option A is wrong. Now A to C, look at A to B, B to C. It means A to C possible. This is correct. So B is false. D to C, look at the closure of D. D closure is D. That's it. It is not any more attributes. So that D to C is not possible. The question is false. So option C is correct answer. Coming to the third question. Relation R of A, B, C, D, E, F with the following set of dependencies. The decomposed relations of R into 3NF. What are the 3NF relations? To find the 3NF relations, first we will find the key for the relation. Now look at here AB closure, if you take it, A, B, C, D, E, F, all the attributes you are getting. So we can call AB is a key. Because C to A dependency is there, A is a prime attribute that can be derived using C, so A can be replaced with C, CB is also a key. And here B is a prime attribute, it is also determined using D, so B can be replaced with D, so AD and CD are the keys. So means what are the prime attributes? The prime attributes are A, B, C and D, and remaining are non-prime attributes. Because remaining are non-prime attributes, here you observe B to E. B is a prime attribute, E is a non-prime attribute, we call it as a partial functional dependency, PFD. Right? E to F, it is a non-prime to non-prime, it is called transitive dependency. Because partial dependency is there, relation is in 1NF, first we decompose into 2NF. How? By taking the closure of partial dependent. That is B closure. When you take the B closure, B, E, F you are getting. So satisfying B to E, E to F. The remaining attributes are A, C, D, and the key attribute of the first relation is B. So satisfying the dependency AB to CD. And here we have a transitive dependency, because transitive dependency is there, relation is in which normal form? Second normal form, but not in the third normal form, because my question is about third normal form. So further decompose. So if you further decompose, we can take E and F in one table, so satisfying E to F dependency. So what is left? B, and the key in this relation is E, B2 is another relation. Here AB is a key, there is no partial, no transitive dependencies, relation is in 3NF, and these are the relations in 3NF. Now what are the 3NF relations? ABCD, BE and EF. ABCD, BE and EF is the option B. B is the answer for the question. Now coming to the fourth question, find out the account to details where the balance is greater than 5,000 in both tuple and domain relational calculus from the given relation schema. This is an account schema is given. What is expecting? Balance should be greater than 5,000 and it requires to know the account details. Account details means all attributes. Assuming this is domain variable A, this is B and this is C are the domain variables, or that entire tuple we can call it as T. Now T is a tuple such that the tuple belongs to account. This is OR operator, so but it requires to be AND, incorrect. It is OR operator, incorrect. It requires AND operator. And the tuple should be the account tuple and balance should be greater than 5,000. Okay, it is correct. Second one is ABC. ABC belongs to account, but here the OR operator is there, it is incorrect. But here you see T belongs to account and the tuples of balance greater than 5,000 is correct. And ABC belongs to account AND operator, it requires AND operator not OR operator, and balance greater than 5,000 is correct. So answer for the question is option D. Coming to the fifth question. Consider B tree where size of the node is 512. Size of the node is 512. Search key field 9 bytes. It means the block size is 512 and the key size is 9 and block pointer is 6 and data pointer we call 7 bytes. The question is the number of index records in level 2. To find the number of index records, first it requires to find the order. Now, so it is a question is about B tree. To find the order of B tree, and we just recollect what is the structure of a B tree node. B tree node should have n index records, n pointers and n minus 1 index records. N pointer, each pointer is 6 bytes. N minus 1 index records. Index record is nothing but key and record pointers. That key is 9, record pointer is 7. The total size should be less than or equal to the block size. The block size is 512. When you solve this equation, you will get 6n plus 16n minus 16 less than or equal to 512. That is 22n less than or equal to, when this minus 16 comes to this side, it becomes 528. And n less than or equal to 528 by 22, that is exactly 24. The order is 24. Because order is 24, it is asked about in level 2, in 2 level B tree. In level 2 in B tree, how many records can be stored? So it is simple like formula. The number of records is equals to order to the power of levels minus 1. Order to the power of levels minus 1. Level plus 1 minus 1. This is will be used to find how many records in L levels. But when I have to find the number of records in the Lth level, because in level 2 it is asked. Say if I am talking about the root will have one node and how many pointers? 24 pointers. 24 pointers means 23 records you can see. In level 1, how many nodes? 24 nodes and 576 pointers, correct? 576 pointers, 24. Each node will have 24 pointers, 24 into 24, 576 pointers. It means in level 1 you have 575 records. When it comes to the level 2, there are 576 nodes and each node will have 24 pointers, means 576 into 24, that is 24 into 24, 24 cube, okay, 24 cube, like see, 24 to the power of 1, 24 to the power of 2, and here you can see how many pointers in this, 576 into 24. So what is the value it will come? The value it comes will be equals to something around 576 into 24, and okay, this is a number of pointers in it. And but look at the point is 576 nodes are there. Each node will have how many records? The 576 nodes, each node, because order is 24, each node will take 23 records. Each node will take 23 records. When you solve 576 into 23, here the pointers are not required because the question is about number of records. So 576 nodes, as you know that every node will have 23 records because order is 24, the number of pointers are 24 and the records are 23, 576 into 23, which is equals to 13,248, and it means in the second level the number of records to be stored is 13,248. And look at the sixth question. If there are two transactions of 2 and 3 operations respectively, then the number of non-serial schedules. The question is about non-serial schedules. When you will have to find the concurrent schedules, we have a formula 2 plus 3 whole factorial by 2 factorial into 3 factorial. 2 plus 3, 5 factorial. 5 factorial by 3 factorial will give you 20 by 2, which is equals to 10. The number of concurrent schedules are 10. Because with the 2 transactions, the number of serial schedules are 2 factorial, which is equals to 2. The question is about non-serial. As you know that concurrent schedules will have in turn in it serial schedules. So the number of non-serial schedules are 10 minus 2, which is equals to 8. That is an option C. Next, question number 7. Suppose that a transaction P has been running for several days. What does it mean? P is the old transaction. Now P is old transaction and a new transaction Q starts up. Q is new transaction. Now Q is new transaction means it is a younger transaction. P is a older and Q is a younger transaction. Which of the following is true? Simple. In a weight dice system, if P needs a resource, what is P? Older. What older should do? Wait. But what it is given? Then P aborts, it is wrong. In weight die system, Q needs a resource. What is Q? Younger. What younger should do? Die. But what it is given? Weights. Incorrect. In wound weight system, if P needs a resource held by Q, what is P? Older. What older should do? Wounds younger to die. Yields Q to abort. So correct answer is option C. And coming to the eighth question, consider the following table: marks, student ID, student name, subject 1 marks, subject 2 marks. Examine this select statement based on marks table. The query is select subject 1 plus subject 2 marks as total, comma student ID from marks, where subject 1 marks greater than average of subject 1 marks. Here you observe what we are using, where class. In the where, what we are using? Aggregate functions. Can aggregate functions allowed in the where class? No. Simple. Straightforward, it is an error. But look at here, what is the result of the select statement? The statement returns an error, error, error. Okay, execute successfully is wrong. Okay, error. But it is mentioned error in select class? No. Error in where class? Yes. Error in order by? No. So what is the correct answer? Option B. The ninth question, consider a relation R of A, B, C, D, E, F, G, H, FDs given. Find the partial dependency. Simple. What is the key? AB. Why? AB closure contains all attributes. A, B, C, E, F, G, H. A, B, C, E, F, G, H. D is not getting. With A, we are getting D, so AB is a key. When AB is a key, what is the partial dependency? Left hand side is prime attribute, right hand side is non-prime attributes. So it means A to D is a partial functional dependency. And these are the 9 questions in the mock 1 related to DBMS. Here I am going to teach the questions of compiler design also. Now, look at the questions of compilers. The context-free grammar, it is mentioned, and the grammar is S tends to SBS, S tends to A. By looking this, we can understand this is a left recursive as well as right recursive, so it is ambiguous grammar. First thing, ambiguous, it is unambiguous wrong, has unique leftmost. If it is ambiguous, unique condition may not be true for certain input strings. So I just removed it. And here ambiguous, but there is a unique derivation for AB, AB, A. So AB, AB, A, by looking we can understand. So S tends to A, S tends to S, B, S. We have to apply as a first production. So we'll get B, either this or this. Suppose this B, I'm assuming it as the second one, or it can assume it as third one. Suppose if you assume it as second one, this S can be A. If you assume that B is the second one, then this S should be not just A, this S should be another alternative. What is the other alternative? The other alternative is A, S, A. Something, sorry, not ASA, I have to call S, B, S, because one more B has to be derived. So means at this point we have a 2 possibilities. Because at that point we have a 2 possibilities, is it giving the unique derivation tree? Wrong. So what is left? Option B is the answer. Now look at, consider the code. Some for loop is given, some statements are given, where S is a large block of code. The question is about loop unrolling. What is loop unrolling? Duplicating the body of the loop for multiple times. Here look, loop unrolling can be used to replace the code by S comma S. S is the body of the loop. The body of the loop is replicated. So answer for the question is option A. In compilation process, symbol table is used to manage the attributes information. As you know that what symbol table stores the attributes and the related information. Which of the following phase uses the symbol table to initialize or create the entries of attributes for the first time? As you know that attributes entries are going to be done in the lexical analysis phase. So answer for this question is option A. Here you look at, consider the operator precedence grammar. So grammar is given, and do remember the grammar given is ambiguous. Why? It is left recursive as well as right recursive. Consider the relational table for a bottom-up parser. Some options are given. Plus is right associative. So how to check right associative? Check precedence between two pluses so that you will get to know the precedence is left or right. So between two pluses we have a less than. Less than means which place is given highest priority? Right side. Means it is right associative. Okay, it is perfect. Star is right associative. So to know associativity of star, we have to check the relation between two stars. Between two stars, we have a greater. Greater means the star is having left associativity. Star is left associative. But what it is given? Right associativity, wrong. And star is left associative, correct. And plus is also left associative, but plus is right. So incorrect. Star has higher precedence than plus. So check relation between star and plus. Between star and plus, we have a lesser relation. It means plus has higher precedence, not star. So plus is high, star is not higher precedence, wrong. So what last statement? Plus has higher precedence than star. Just look at between plus and star. What is the precedence we have? Greater. Greater means plus is having higher precedence. So answer is option D. That's it. It's very simple. And question number 46. Here, consider the SDTFs. Some grammar is given. E tends to E star E, E plus E, E tends to ID. Wherever ID is there, this sum is 1. Wherever plus is there, that sums are added. Wherever multiplication is there, that sums are multiplied. Now the question is the output of this A, B, C, D, E. How many identifiers we have? 1, 2, 3, 4, 5. So what is the grammar? It says, what is the syntax directed translation? It says, wherever ID is there, it is to be 1. Wherever plus is there, it is to be added. 1, 1, 1, 1, 1. This is addition of all identifiers. So 1 plus 1 plus 1, which is equals to 5, is the answer. It's as simple as this. The method which merges the bodies of two loops. Merging the bodies of two loops is called jamming. We call it as a loop jamming. Look at, consider the following SSA code. How many minimum variables required in equivalent 3 address code? In TSC code, how many minimum variables are needed? So in TSC, what we have to do? We have to avoid the usage of new variables. Suppose A star B is there. So we should not assign to new variable T1. Instead, we can use A. But here you look at A, because T1 is used here. With this T1, I replaced with A. This T1 should be A star C. This is assigned to new variable T2. So instead of T2, I can go with A again, because T2 is going to use here. This is A, so here also A. But usage of this T2 as A will affect the value of this A. So don't use this as A. So what you can do, instead of using this as A, you can use it as C. That could be better. So here I am using it as C. Here also I can use it as C, because this A is not going to be affected. Next, A minus B equals to A. Look, A minus B, this T3 I can assume it as A. The T3 is used here, this is A. finally what is this? A divides C, that is T4. Now this is a final result, you can assign to either A or C, no issue. So finally what variables I have used? A, B and C. So the number of variables are 3. That's it. So that's about the questions of databases and the questions of compilers. Hope you have enjoyed it. Thank you. Wish you good luck.
So as part of this BARC Mark 1 paper discussion, here I am going to deal with computer network subject and operating system subject. So coming to this computer network subject questions, the first question is, a system has 5 layers protocol hierarchy. Applications generate the messages of length 1000 bytes. At each of the layer, a 10-byte header is being added. What is the fraction of network bandwidth wasted on the headers? So the question is clearly mentioned that there are 5 layers. There are 5 layers. Let's say L5, L4, L3, L2 and L1. And you are having size of the message is 1000. So here you are having 1000 bytes of message. To this, at each layer you are appending 10 bytes of header. So to this you are appending 10 bytes, right? So 1000, and again you are appending another 10, another 10, another 10, another 10. So which means that you are appending 5 headers here, right? So 5 headers, so total you are having 50, right? 5 headers, 5 into 10, 50, plus this particular 1000, which is coming to 1050. So M plus H, how I got this 1000 plus H, 1050, M is 1000 plus total header. What is the total headers? 5 headers are there, 5 into 10, 50. So that is the way how I am getting 1050 here. Out of this 1050, how much network bandwidth is wasted on the headers? As it is speaking about headers, it is just by 50, right? H by M plus H. This is the formula that we have used to solve this particular question. So 50 by 1050 if you consider. So if you use calculator here, 50 divided by 1050, if you can see, 0.047. So 0.047, which is this is the bandwidth, 0.047. This much bandwidth is getting wasted, so that you can see that option B is the answer for this question. Okay, as this is what the explanation for this question. 0.047 is equivalent to 0.048. So option B is the answer for this question. So let's move to the next question. So in TCP congestion control slow start algorithm, current congestion window is 16 MSS. Timeout occurs at sender end. Then what is the congestion window size at sender end during the 5th transmission? Initial congestion window, it is not condition window, it is congestion window. Initial congestion window size is 1 MSS. Right. So for example, what the question is saying that current congestion window size is 16 MSS and then timeout occurs. It means you have done additive increase phase and you have done, okay, you have done slow start phase, then additive increase phase, and here timeout is occurred. By this moment you are having 16 KB of data. 16 MSS, let's suppose 16 MSS is your window size. Then timeout is occurred. So you know that when there is a timeout is occurred, congestion window size by 2, congestion window size by 2, right? So timeout is occurred, then you are calculating the congestion threshold. At this congestion threshold, what is the formula? Which is congestion window size by 2. So congestion window size is 16 by 2, which is 8 MSS. 8 MSS is the congestion threshold here. So now what we are going to start, during the first transmission, one segment is being transmitted. One segment in the sense what? 1 MSS. During the second transmission, what we are doing, we are sending 2 segments. 2 segments in the sense 2 into 1 MSS, 2 MSS. During the third transmission, we are sending, as it is slow start phase, it is 4 MSS. 4 into 1 MSS, which is 4 MSS, right? Then during the fourth transmission, it is it should be 8 MSS. 8 MSS in the sense 8 into 1 MSS, which is 8 MSS. And 8 MSS is the congestion threshold. Then during the 5th transmission, what can be the window size? Since you have reached the congestion threshold, once you have reached the congestion threshold, the additive increase phase will be started. So since it is additive increase phase, 1 MSS gets added. 1 MSS if I add, then it is coming to 9 MSS. So during the 5th transmission, the sender is able to send 9 MSS of the window size. So that option B is the answer for this question. Okay, right. Let's move to the next question. So coming to this question, consider the following network. This is the network it is being given. The links are full duplex, okay. A large file is to be sent from node A to node C. node A to node C, and the propagation speed is 2 into 10 power 8 meters per second, and the packet size is 512 bits. What is the total time to have a successful transmission between the node A and node C? What is the total time to have a successful transmission between node A and node C? So first what you have to do, node A should transmit the data. So for transmission of the data, first Tx is being taken, and then Tp, and then Tp again, right? And after that, so since it is successful transmission, you are looking for acknowledgement also. So what we are going to do here, so for example, the question is clearly mentioned that links are full duplex, that's okay. A large file is to be sent. So packet size is given 512 bits, L is equals to 512 bits. L is equals to 512 bits. And this is having 512 Mbps. The bandwidth is 512 Mbps here. 512 Mbps. Here 512 Mbps. Then you can calculate the Tx. What is the Tx? L by B. L is 512 by 512 into 10 power 6. Then it is coming to, what is that? 1 microsecond. So 512, getting cancelled. So you are getting 1 microsecond. Then, if you consider Tp, Tp is equals to d by V. What is the distance here? 10 kilometers. So distance is 10 kilometers, 10 into 10 power 3 by, what is the distance? 10 kilometers by, both the links are having 2 into 10 power 8 meters per second, 2 into 10 power 8 meters per second, 2 into 10 power 8 meters per second. So this you can write as 10 power 4 by 2 into 10 square into 10 power 6. So 10 square, 10 power 4 gets cancelled, 10 square can be remaining. So 10 square means 100, 100 by 2, 50. So 50 microseconds is your Tp. 50 microseconds is your Tp. So this is what Tp here, right? So the Tp value up to this link is 50 microseconds. And the Tx value is how much? 1 microsecond. Then coming to here, this is bandwidth. Bandwidth is what? From B, you are having bandwidth of 256 Mbps. So coming to here, L is equals to the same size, 512 bits. And bandwidth is 256 Mbps. So from these two, you can calculate the Tx, which is L by B, 512 by 256 Mbps. So 512 by 256 Mbps, which is coming to 2 Mbps, or 2 microsecond you can say. 2 microseconds. Here Tx value is 2 microseconds. Okay? Tx value is 2 microsecond. And the Tp value, what is the Tp? Here the distance is 3 kilometers. So Tp is equals to d by V, 3 into 10 power 3 by 2 into 10 square into 10 power 6. So here this gets cancelled. So this is coming to what? 30 by 2, 15 microseconds. So Tp is 15 microseconds, Tx is 2 microseconds. Here Tx is 1 microsecond and Tp is 50 microseconds. So from this link to this link, you are having Tx plus Tp. And from this link to this link, you are having Tx plus Tp. Okay? So Tx plus Tp. So then it is coming to, here Tx is what? 1 microsecond and Tp is 50 microsecond, total 51 microsecond. And coming to here, Tx is how much? Tx is how much? As the bandwidth is being changed, 2 microseconds. Here 2 microseconds of the Tx. And Tp, as the distance is being changed, it is coming to 15 microseconds. So in one transmission, total transmission, what it is going to be? Here 51 microseconds and here it is 17 microseconds. Total you are having 68 microseconds in one way, 68 microseconds. But the question is speaking about a successful transmission. So since it is successful transmission, what will happen? So this will be returned, right? So it means the acknowledgement signal can be returned. Then the Tp up to this, what is the Tp value? 15, TP value is 15 microseconds, and coming to here, TP value is 50 microseconds. Here 15 and here 50 microseconds. Am I correct? So the distance from C to B is 3 kilometers. So TP for this is 15 microseconds, and here it is 50 microseconds from B to A. So that is totally 65 microseconds is the time taken for the acknowledgement to come back from C to A. Okay. Then this is one way acknowledgement. Whenever the A got acknowledgement, then it is called a successful transmission. That is why it is 65 microseconds from here to here. Then this way if you do, Tx plus Tp 51 and Tx plus Tp 17. So what it is totally 68 microseconds. So this way 68 microseconds, this way 65 microseconds. Totally you are getting 133 microseconds. So 133 microseconds is the answer for this question. Okay, right. So let's move to the next question. So coming to this, consider CSMA CD network running at 512 Mbps over 1000 meters cable with no repeaters. The signal speed is equals to speed of the light. What is the minimum frame size? So the bandwidth is 512 Mbps. Distance is 1000 meters. The signal speed, which is V, is speed of light, which is 3 into 10 power 8 meters per second. And what is the minimum frame size? You know that in the CSMA CD, we have 2 into D by V into bandwidth. This is what the condition that we are having. So 2 into, what is the D? 10 power 3 by V, 3 into 10 power, you can say 3 into 10 power 5 into bandwidth is 512 into 10 power 6. Okay, so then this is going to be how much? 10 power 3, 10 power 3 cancel, 10 power 5, 10 power 6 cancel. So here you can have 10. So this is going to be how much? 5120 into, so 5120 into, this is 5120, right, into 2, 10,240. So 10,240 divided by 3, if I do 3413.3, let's say if you consider it is so 3413.3 bits if you consider, but options are not in terms of bits, they are all in terms of bytes. So 3413, or else you can say 14 divided by 8, which is coming to 420, which is divided into 426.75. So 426.75, which is very close to 427. So that 427 bytes is the answer for this question. So, or you can say 427 bytes, approximately this is. So option A can be the answer for this question. Okay. So let's move to the next question. So the fiber optic link length is 20 kilometers, packet size is 2 KB, bandwidth is 100 Mbps, and one connecting device in the link is having the queuing delay of 40 microseconds. Velocity of the signal is being given 2 into 10 power 5 kilometers. The total time for the packet to reach to destination is. Okay. So the fiber link is having length D is equals to 20 kilometers. And the propagation speed is given 2 into 10 power 5 kilometer per second. The bandwidth is being given 100 Mbps. And the packet size L is given 2 kilobyte. And the queuing delay is being given 40 milliseconds. I can write queuing delay is TQ 40 milliseconds. What is the total time for the packet to reach to the destination? So first you have to calculate transmission time Tx. So Tx is equals to L by B. This is in terms of bytes, this is in terms of bits. So 8 into 2 into 10 power 3 by 10 square into 10 power 6. So the question is expecting in terms of milliseconds, so let's consider milliseconds. So this is, I can write as 10 power 3 into 10 power 3. So 10 square 10 power 3, total 10 power, you can write like this. So what we can say, so 10 square and 10 power 3. So this 10 power 3, if I write like this, this is 10 power 3. This 10 power 3, 10 power 3 cancel. Then I am having 8 into 2 by 100, which is 0.16 millisecond. This is what my Tx. Then here Tp. What is the Tp? D by V. So D is 20 kilometers. So 20 into 10 power 3 means I converted that into meters. Okay. This I can write as 2 into 10 power 5 into 10 power 3. So this cancel. This and this cancel. Right. And here I am having 10 square. 10 square. 10 square and this is 10. So 1 by 10. So this is going to be 0.1 millisecond. 0.1 millisecond. So D is 20 kilometers and V is 2 into 10 power 8. 10 power 3, 10 power 5 cancel. Okay. So then this is coming to 10 square and here 2, 10 times. This 10 and this one gets cancelled. Here 10 can be remaining and here 1, 0.1 milliseconds. Correct. So TP is what? TQ is 40 milliseconds. So overall now, if you can check, what is the total time that is being taken? So total time for the packet to reach to the destination. Total time for the packet to reach to the destination. So therefore the total time is equals to, here TQ is 40 milliseconds. So 40 milliseconds, which is first Tx will be happen and then the fiber link, okay, the fiber link and one connecting device is there. So which means one connecting device is there. Let's say this is A, this is connecting device and then B. So this is what it is speaking about. One connecting device is there. So through this connecting device that A and B should able to transfer the packet. Correct? So first Tx can be happen and then Tp can be happen and then TQ can be happen. Correct? And after that this particular connecting device, if it is having store and forward device, then again there is a possibility for one more Tx. There is a possibility for one more Tx. And then TP, one more TP we can have. Okay. So the fiber optic link of length is 20 kilometers, packet size is 2 kilobytes, bandwidth is 100 Mbps and one connecting device in the link. So there is only one link here. So this is one link, via this the total packet is being transferring. Okay. TQ is being given 40 milliseconds. So TQ is 40 milliseconds plus TP is 0.1 millisecond plus Tx is 0.16, right? So this way, if we can see, one more Tx, even it is not going to be equal with any of these options. So let's check the question statement one more time. We can come back to this question one more time. Let's go ahead with the next question. So what is the next question that we are having here? So it is based on stop and wait protocol. So stop and wait protocol, so packet size is 2000 bytes. And the propagation delay TP is given 25 milliseconds. Bandwidth is being given 2 Mbps. So from these two, Tx if you can calculate L by B. This is in terms of bytes. So 2 into 10 power 3 into 8 by 2 Mbps, 2 into 10 power 6. Okay. So then here it is in terms of millisecond, better express this is also in terms of millisecond, so that I can write this is 10 power 3, 10 power 3. 2, this is 8 milliseconds, Tx is 8 milliseconds, Tp is 25 milliseconds. So A is equals to Tp by Tx. Tp is 25 milliseconds by Tx is what? 8 milliseconds. So 25 by 8, if you can see 3 point, I can say, so 25 by 8, 3.125. So efficiency of stop and wait is equals to 1 by 1 plus 2 into A. So 1 by 1 plus 2 into 3.125. So 3.125 into 2, which is 6.25, plus 1, 7.25. So 1 divided by, okay, so 3.125 into 2, 6.25, plus 1, 7.25. So 1 divided by 7.25, if I do, 0.137 I am getting. So among the options, if you can check, yeah, so this is equivalent to 13.7 percentage. So if I express this in terms of percentage, 13.7 percentage is the answer for this question. Okay, so let's move to the next question. So an IP router with the MTU of 1500 bytes has received an IP packet having the packet size of 3404 bytes with a IP header of 20 bytes. Okay, so assuming that this is what your MTU, this MTU is having 1500 bytes. Okay, and this is the packet which is having 3404 with 20 bytes of header is coming onto the router interface. So this, you know that it is being divided into 1480 plus 20, 1480 bytes of data and 20 bytes of header. So therefore, the number of fragments is equals to, so 20 bytes of header. So 3404 minus 20, if we can do, so 3404 minus 20, if I do, 3384. So we are getting 3384 here. So 3384 is the data portion and 20 bytes of header. So 3384 divided by 1480 we have to do. So 3384 divided by 1480, it is coming to 2.28, means 3 fragments you are going to have, 3 fragments. So out of 3 fragments, 2 fragments will have full data. So two fragments. What are the 2 fragments? The first fragment will have 1480. The second fragment also will have 1480. So 1480 plus 1480, 2960, right? So 3384 minus 2960, which is 424. This is having 424. Right, for this, what you are going to do, what you have to calculate? You have to calculate the MF bit, datagram length and offset. Okay, so it is starting with 0 to 479. This is starting with 482, 1482, 2959. And this is going to start with 2960. So 2960. So this is the offset value for this is 0. Offset value for this is 1480 by 8. If you consider 185, and this is 2960 by 8, which is coming to 370. MF bit, if you consider, this is 1, this is 1, this is 0. So the question is speaking about the third IP fragment. Third IP fragment in the sense this one. This is what your third IP fragment. So what are the details you are having verified? Offset value is 370. Yes, offset value is 370. So option A is ignored, option D is considered, right? So based on MF bit is 0, offset value is 370. MF bit is 0 here, right? And offset value is 185, option A is eliminated. Then, which is having MF bit is 0, but option C is having MF bit is 1, so that this is eliminated. So the answer is between D and B, but datagram in the sense it is not speaking about the data, it is speaking about the datagram. Datagram in the sense both header length plus data portion. Header length is what? 20 bytes and data length is what? 424. So 424 plus 20 if you do, 444 you are going to get. So that is the datagram. So 444, yes, MF bit is 0, 370 is the offset, and datagram length is 444, which is option B is the answer for this question. Okay, right. So let's move to the next question. So a system has k layers of hierarchy. Applications generate a message length of L bytes at each layer, and C bytes is the header is being added. The fraction of the network bandwidth used on the messages, the fraction of network bandwidth used on messages. Okay, so we are having k layers. Okay, fine. We are having k layers, and every layer is what is the size of the message here? It message. I mean, the hierarchy applications generate L length of the L bytes of at each layer L bytes. L bytes is getting changed. Okay, L bytes of data is getting changed. This is what your message length. And 5 k layers are there. K layers in the sense, at every layer you are appending C bytes of header, so that your H is going to be C bytes, and number of layers is k bytes. So therefore the next number of what is the total message that you are placing now? Total data is L. Total data is L plus k into C, which is you can say kc. This is what the total data that you are placing. Data plus 5 k layers into C header. Out of this much, what is the network bandwidth that is used on the message? Message it is asking. What is the message? L. So L by L plus k into C, which is matching with option B, is the answer for this question. Okay. So this is what the explanation for this question. If it is a header, then it is going to be C by L plus k into C. But it is speaking about network bandwidth used on the message. That's why L I am using on the numerator. Okay. So L by L plus k into C, option B. Then look at this question. Which of the following uses UDP as a transport protocol? HTTP uses TCP port number 80. Telnet uses TCP port number 23. SMTP uses TCP port number 25. But DNS uses UDP port number 53. So that option C is the answer for this question. Which of the following uses UDP as a transport protocol? DNS. Next, suppose the CSMA CD protocol is used for channel access in the Ethernet LAN for 3 hosts on a LAN. So each host can transmit the data in an ideal slot with the probability of 0.8. So B is equals to 0.8. What is the probability that only one host can transmit? So here how many number of hosts you are having? 3 hosts. So 3 hosts you are having. So each one will get how much probability here? So n into p 1 minus p whole power 1 minus p. So this is the formula that you can see to this is what the formula that you can use. So simply you can substitute these values in this formula. So n is 3 into p 0.8 1 minus p. What is the value of 1 minus p? What is the value of 1 minus p? P is 0.2, 1 minus P is 0.8, and here 1 minus P is 0.2, whole power 0.2. So if you evaluate this expression, let's say so if we evaluate this expression, you are going to get 0.096. So here this is n minus 1, right? N minus 1. Okay. So np into 1 minus p whole power n minus 1. N is 3, so this is going to be 0. Right. So 3 into 0.8 into 0.2 whole square. So if you can consider this one, you are getting 0.096. So which is matching with option B. So this is the formula. So this is what the throughput of your Ethernet, right? The throughput of the Ethernet here, or else you can say the CSMA CD throughput formula. So np into 1 minus p whole power n minus 1. So 0.096, which is option B is the answer for this question. So let's move to the next question. So this is what our next question. So here the propagation delay is 40 microsecond and bandwidth, okay, packet size is given 512 bytes. TP is 40 microseconds, L is equals to 512 bytes, and the question is asking you about the bandwidth. And at what data rate does the round trip time? It means the round trip time equals to transmission delay. It means it is clearly saying that RTT is equals to Tx. TP is 40 microseconds, then RTT is what? 80 microseconds. So this you can write as L by B is equals to 80 microseconds. Then bandwidth we need to calculate. So bandwidth is equals to L by 80 into 10 power minus 6. What is the L value? 512 bytes. So 512 into 8 by 80 into 10 power 6 bits per second. So the question is asking about yes, bits per second. Yeah. So this is totally Mbps now. Now this is 10. So 51.2 Mbps are we have? Yes. So 51.2 Mbps is the answer for this question. Option A is the answer for this question. Okay. So option A is the answer for this question. Next, we are moving to the next question. In UDP datagram, what should be 16-bit checksum value put by the sender if the sender wants to disable error checking at receiver side? See, first thing, UDP is unreliable connectionless protocol, and if you can recall that UDP datagram header format, that UDP datagram header format contains checksum field, but inclusion of checksum into the UDP datagram header is not needed, I mean not mandatory, it is optional. So that is why you can say it is 0. Okay? So because UDP datagram contains checksum field, but as it is unreliable connectionless protocol, inclusion of checksum into the UDP datagram header is not mandatory. You can say it is optional. That is why we can say it is 0. Okay? Right. Next, coming to next question. So given address block 128.112.128.21 needs to be allocated to or distributed 8 different customers with 25 hosts. The network ID of the last address block of the network resulting from the allocation is. So it is speaking about. So look at what it is speaking. So 128, this is what the network. It wants to divide into 28 customers. It has to be divided into 8 customers. And 245 hosts are required. So you know that here 128.112.128.0/21, what does it mean? Here 21 bits are mask bits, you can say 21 bits are mask bits. And 245 hosts, if you want to have 245 hosts, then how many number of systems, what should be the host ID length? 245 hosts. You should require 8-bit host ID, means last these bits are coming to this entire byte. So 128, 112, 128, all these 8 bits are going to be your HID portion. All these 8 bits are going to be your HID portion. And here 128, 112, 7 times of zeros, dot 8 zeros. This is what your HID. 21 bits, here 8 bits, here 8 bits, and here 5 bits. Up to this is what your network ID. And this is what your subnet ID. So 3-bit subnet ID you are having. So with the 3-bit, how many subnets you can create? 8 subnets you can create. That's what it is asking. 8 subnets you are asking. So this is the first subnet. And second subnet is 001, 010, 011, 0, this is going to be 100, 101, 110, 111. Right? So this way, if you can see, this is going to be 128 plus 112 plus this is 128 and this is 7. As the question is asking about network ID of the last address of the networks resulting from the allocation is. Last address in the sense this one, 111. So here 128. 128 plus 7, how much? 128. If you convert this into binary, you are going to get 127 plus 8, which is 135. 135.0/24 is the answer for this question, because network ID bits are 21 bits and the SID bits are 3 bits. Totally you are having 24 bits and totally this is 135. So 135 is the answer. See this particular 5 bits and this last network. 4 times of 0 and 111. Totally you are coming to 135. So option C is the answer for this question. Let's come into the next question. So suppose the round trip propagation delay 10 Mbps Ethernet has 24.2 microseconds. The network has 48-bit ignorable jamming signal. Then what is the minimum size of minimum frame size in bits? So round trip propagation delay for the Ethernet frame, it means R value is given 24.2 microseconds. Bandwidth is given 100 Mbps. Of course, 48-bit jamming signal is being given, but this is saying that ignorable. So simply you know that L is equals to, this is 2 into TP by 2 into TP into bandwidth. This is you can write as RTT. So RTT, so first bandwidth is 100 into 10 power 6 into 24.2 microsecond. Microsecond in the sense 10 power minus 6. This is all in terms of bits. 10 power 6, 10 power minus 6 gets cancelled. So this is 100 into 24.2. So 100 into 24.2, if we can check, 100 into 24.2, if we can check, 2420 bits you are getting. 2420 bits you are getting. Okay. So this is the way how you can say that option B is the answer for this question. Option B is the answer for this question. Next, coming to this question, one question we left here. Yeah, so this question I hope so we left. So what is this question basically? Let me erase this. Right. So the fiber optic, so first let us see, the fiber optic link length is 20 kilometers, packet size is 2 kilobytes and the bandwidth is 100 Mbps. And one connecting device on the link with the queuing delay 40 milliseconds and the velocity of the signal is given as 2 into 10 power 8. So the total time for the packet to reach to the destination. So first let us consider the distance is 20 kilometers. So let me check the values are correct or not. So So 20 kilometers, yes, 2 kilobytes, right, 100 Mbps, right, and the queuing delay is 40 microseconds, yes, 2 into 10 power 5 kilometers per second, correct. Right. So D is 20 kilometers, propagation speed is 2 into 10 power, let's say this is 8 meters per second, and this you can write as 20 into 10 power 3 meters. Packet size L is 2 KB, 2 kilobyte, which I can write as 2 into 8 into 10 power 3. I just converted this into bits. and bandwidth is 100 Mbps. So from these two, TP I can calculate. What is the TP? D by V. So D by V, this is 20 into 10 power 3 by, this is 2 into 10 power 8. So the question is expecting in terms of milliseconds. Okay. So milliseconds in the sense, this you can write as 20 into 10 power 3 by 2 into 10 power 5 into 10 power 3. So this cancel. You are getting what? 10 power 3 and 10 power 5. You are getting here 10 power square, right? 10 square. So this is coming to 0.1 millisecond only, it seems. So packet size is 2 kilobytes. Let's consider this one, Tx, which is L by B. 16 into 10 power 3 by 100 Mbps. 10 square into 10 power 6. This you can write as 10 power 3, 10 power 3. So 10 power 3, 10 power 3 cancel. So if you want to express this in terms of milliseconds, then this is also getting something like 0.16 milliseconds. So 0.1 millisecond and 0.16 milliseconds you are getting. Yes, so this is where we are getting. So this is asking you in terms of microseconds. The units are microseconds, not milliseconds. So this is microseconds, okay? Not milliseconds. A slight printing mistakes, microsecond. So if it is microsecond, then you check the answer, very easy now. So D is equals to 20 kilometers. And this is 2 into 10 power 8 meters per second. This you can write as 20 into 10 power 3 meters. So from these two you can get the TP. TP is equals to 20 into 10 power 3 by 2 into 10 square into 10 power 6. So this 10 times and this gets cancelled. Total you are getting 10 into 10, 100 microseconds. TP is 100 microseconds. So now L is 2 into 10 power 3 into 8 bits. Bandwidth is 100 Mbps. 100 into 10 power 6 bits per second. So from these two, Tx is equals to L by B. So L is equals to 16 into 10 power 3 by, this you can write as 100 Mbps, 100 Mbps into 10 power 6. This cancel. So you are getting here 160 microseconds. And TQ is being given. What is the TQ? 40 milliseconds. So the question is asking you that the total time the packet to reach to the destination. To reach to the destination in the sense, first TX should be there, then TP should be there, and then TQ must be there. So TX is what? 100 microseconds plus TP is what? 160 microseconds plus TQ is what? 40 microseconds. Totally it is coming to 300 microseconds. See, this is what? So this is a simple printing mistake is this is microsecond. Because of this, lot of time got wasted. Okay. So 300 microseconds, that is matching with option B. Option B is the answer for this question. So with this I can say computer networks related questions all are being solved. So then we can start operating system subject. So coming to the operating system subject, let's look into the questions of operating system. So if you check this question, consider disk Q holding request to the following cylinders in the listed order 116, 22, 11, 75, 185. Some order is being given and C-look algorithm is being asking. And what is the order? Okay. So assuming that there are total 100 cylinders. So that is ranging from 0 to 199. So first I can have 3 and after that I can have 11. Okay. After that I am having 22. After that I am having 22, then I can have 75. And then I can have 87. And after that 88. And after that 100. And then 116. And after that 185. So current head is at 188. So here it is. As it is C look, and it is clearly mentioned that the head is at cylinder 88 and is moving towards the higher number tracks. Higher number track is what? 185. So it is traveling towards the 185. So from here to here 100 it goes, then 116 it goes, and then 185. So mind this is not look, this is C look. C look won't touch at one end. It travels up to the last disk request and then it takes the reverse direction, and without servicing it comes to again this one, 3 last disk request in the reverse direction, and then it starts servicing all these remaining disk requests. This way the disk request gets serviced. So first it starts with the 88 and then it goes to 100, 116, 185, and then 3, and then 11, and then 22, 75, and 87. So option A is the answer for this question. This is the order. First 100 is being accessed, and then 116, and then 185, and then 3, and then 11, and then 22, and then 75, and then 87. So this is what you are. So it doesn't touch any end point of the disk. It travels in higher disk request up to the last disk request that is present in the higher disk request, and then it takes the reverse direction, and then it travels up to the last disk request in the reverse direction, but it does not touch the end point. If it is look, then it can touch, I mean if it is C scan, then it touches both end points, but it is C look, no, it won't touch both end points here. If it is scan, it touches one end point. Okay, so this is what option A is the answer for this question. Next, look at this question. An OS uses preemptive priority based scheduling. The priority of a process is directly proportional to its remaining burst time. Okay, this type of scheduling is similar to. Okay, so OS uses preemptive priority schedulings. Please mind this. Preemptive priority in the sense higher priority process will be executed first. Higher priority process. So the priority of the process is directly proportional to remaining burst time. Directly proportional to remaining burst time. So it means that if the burst time is high, then the priority also high. Simple. Directly proportional. If it is inversely proportional, then burst time should be less, then the priority can be high. But here, it is given that the priority of the process is directly proportional to the remaining burst time. So this type of scheduling algorithm is similar to what? This is similar to LRTF. It is not SRTF or SJF. Reason, in SJF, if your shorter job, I mean the priority, if you want to have high priority, your execution time should be less, means inversely proportional. If it is high, and this is going to be low. If it is low, this is going to be high. This is called inversely proportional. This is what in both SRTF and SJF. But here the question is speaking about the priority is directly proportional to burst time. So that LRTF. Option D is the answer for this question. Okay, so right. So let's check with the next question. So look at this question. Consider a machine with the 256 MB physical memory and a 36-bit virtual address space. If the page size is 4 kilobytes, so L is given 4 kilobyte. 36 bits address space, LAS is equals to 2 power 36 bytes, let's suppose. Conventional page table size and the inverted page table size it is asking, assuming that the page table entry size and the frame table entry size both are same. Okay, so 256 MB physical memory I am having. So 256 MB in the sense which I can write as 2 power 28. 2 power 28, it means that your physical address is 28 bits. And the page size and the frame size both are same. It is 12. So, you know that physical address is being divided into frame number and offset. Offset is what? 12 bit. And out of 28, if 12 bits are here, then this is 16. And you know that entry size, page table entry size format is what? Frame number plus bookkeeping information, but this is optional. No need to give. But frame number is mandatory. It is already given 16 bits, which I can write as 2 bytes. So, logical address space is 2 power 36 bytes. It means your logical address is 36 bits. Then this is being divided into page number and offset. Offset is 12 bit. Out of 36, if 12 bits are here, then 24 is your page number. 24 is your page number. So therefore, the number of entries is 2 power 24 into each entry size is 2 bytes, which is 2 power 25 bytes. 2 power 25 bytes in the sense 32 MB. 32 MB. Among the options, if we can check, option D is the answer, 32 MB. But if you can check with the inverted page table, this is what your conventional page table size, CPTS. But inverted page table size, IPTS, if you consider, how many entries you are having? 2 power 16 into 2 bytes, which you can write as 2 power 17 bytes. 2 power 17 bytes, how you can write? 128 kilobytes. So, option D, this is the way how we are getting. Okay. So, let's move to the next question. So, in a semaphore, any Android OS, in a semaphore, any Android OS, okay, in a system maybe, which of the following criteria is most important for app developer? For app developer. Android OS. For app developer, in the sense there are so many apps may be there, so that whenever you are using Android operating system, obviously you are looking for what? You are looking for response. So that response time should be the answer for this question. Response time should be the answer. Option C is the answer for this question. So let me check whether it is a semaphore. Okay. So, coming to this question, fork related, see, this is what, if fork is equals to 0, then this is your child process, right? And this is your parent process, right? So, child is using A is equals to A plus 5, parent is using A is equals to A minus 5. So U, V be the values printed by parent. So U and V are the values printed by parent, and X and Y are the values that are printed by child. So X and Y are the values that are printed by child. So the question is, here it is mentioned that V is equals to Y, it means it is speaking about the logical addresses. So virtual addresses are same for the parent and child, but the physical addresses are different. Okay? So V is equals to Y. So for example, here child virtual address is part of Y, parent virtual address is part of V. So that this is U value, this is X value. So assuming that A value is 5, then your X value is coming to 10 and your U value is coming to 0. Then verify among the options, X is 10, U is equals to 0. So U 0, X is equals to 10. So option A, if you can check, 0 is equals to X plus 10. X plus 10 is X is 10. So is it equals to? No. Then, but this is not, because virtual addresses are actually same, so that you can ignore B and D here. So the answer is coming to C here. Reason U is equals to 0 plus 10 is equals to X value is 10. 10 is equals to 10, which is true, and virtual addresses are equal for the parent and child. So this is a way how you can get option C is the answer for this question. Okay, right. So coming to this question, so this is a SJF direct question it is. All are arrived at the same time. So if you draw the Gantt chart for this system, so instead of here, I can write the Gantt chart here. Yeah. At 0, all 5 processes arrived. But which process will be started among all of them? Lowest burst time. P2 is having the lowest burst time, so that P2 will hand over to the CP, gets executed till 1. Then P1 will execute up to 3. Then P4 will execute, P4 up to 7. Then you are left over with what? P3 and P5. P5 will execute now up to 12. Then P3 will start its execute up to 20. So verify. 8 plus 2, 10. 4 plus 5, 9 plus 1, 10. Yes, 20. Fine. So now completion time. So P1 is finished at 3. P2 is finished by 1. P1 is finished by 3. P2 is finished by 1. And P3 is finished by 20. P4 is finished by 7. P5 is 12. So turnaround time. Turnaround time is same as your completion time because arrival time is 0. So 3, 1, 20, 7 and 12. So the average waiting time it is asking. So waiting time is equals to turnaround time minus burst time. So 3 minus 2, 1. 1 minus 1, 0. 20 minus 8, 12. 7 minus 4, 3. 12 minus 5, 12 minus 5, which is 7. Then it is coming to 7 plus 3, 10. 10 plus 12, 22, 22 plus 1, 23. So 23 by 4 is your average waiting time. So 23 by 4, what it is? 23 divided by 4, if you can check, 5.75. So 23 divided by, so this is 12 plus 1, 13, 16, 23. So 23 divided by 4, you are having 5.75. Five processes, no, sorry. So 5. So 4.6 you are going to get. Yes, option C is there. 23 by 5, this is what your average waiting time. I thought of 4 process, but here you are having total 5 process. So 23 by 5, 4.6 milliseconds. So this is the answer for this question. Next. Here it is speaking about the longest remaining time first. If you can check this question, okay, so if you, I just giving you how to solve this. So at 0, first P1 will start its execution because 0 is arrival time with 3. So since it is alone process, we can start its execution and it's going to be executed till 1 unit. By 1 unit, who is coming? P1 is there with 2 and P0 is coming with 8. So now P0 will go on to the CPU because it is having higher burst time. Now it is going to be executed till how long? So arrival time here, both are same, P0 and P2. So P2 also coming with 5. Yeah. So verify now. P0 is highest, so that P0 went. And how long it is going to get executed till? 4. Because till you can say that 4. Yes, 4. By 4, P1 is there with 2. P0 is there with 5 because 3 units. And P2 is there with 5. So then burst time is same. Arrival time, if you can check, P0 and P2 both are arrived at the same time, then lowest process ID, you can check P0 will start again. So P0 will again resume up to 5 it gets executed. So then by 5 you are having P1 with 2, P0 with 3 and P2 with 5. Then P2 will go. Right, so up to 4 it gets executed, right? So up to 4, yeah. So P2 will get executed till 6. So then by this movement P1 is there with 2, P0 is there with 4, P2 is there with 4. Then who will go? P0 will go. Then 7 up to 1 unit, 1 unit it goes. So then P1 with 1, P0 with 3, P2 with 4, then P4, sorry P2, up to 8. Then P1 with 2, P0 with 3, P2 with 3. Then again P0 will go up to 9. So this way if you can check, you are going to get 13 number of contact switches by ignoring first and last, okay? First and last. You are going to get around 15 total contact switches by considering first and last, but it is asking you ignore the 0 and at last, so that 13 contact switches you can have. So option D is the answer for this question. So like this we are having some questions with respect to operating system subject, okay? So they are all very easy questions. So I hope you are clear with the provided solutions of both CN and OS. Thank you.